connect. Talk to me now if you're amped, if you're hamped, if you ham on whole wheat for the knowledge that's zero. Nothing, nil, nada nor zilch. Residual randomness, spat toxic waste. I'll trust your setup like I trusted your mama. Jokes. People do your best to take them, says pickle heart liver thief. I like to make them. I like my curves like my workout machines. Elliptical. My products use factors impractical. Might not be post-quantum, but whoever is getting them's glad that they got them. They call me SNARK bitter, but I ain't no Sith. My homie Digger, it fell off a cliff. And free fall inspection, cryptic calculation. Not a main, not a should, not a might, but a must. Homie big terminal philosophy. Give me SNARK, give me proof, give me bill. I expect consensus and nothing less. We'll work for tip sets. You try to grind, try to toss my chain. Well then, fork you, let me explain. The coin is the file and the file is the coin. It's a transubstantiation racket, a crypto-economic packet. It's a virtual state machine, replicated and proven to be obscene. Several geopolitical jurisdictions, Xing out engineers like historical fictions. We call it wartime and it ain't no joke. It's a mountain of thermal paste, billowing smoke. It's a problem hard and indiscreet. It's a logjam of bad RAM and it's death robust. Picture a puzzle in. Rewrite it and rest. I'm really worried, how worried I'm dead. I broke the proof, well that makes me sad. But I might have a plan to make it alright. I think you just asked me to stay up all night. Give me SNARK, give me proof, give me fill. I expect consensus and nothing less. We'll work for tip sets too. You try to grind, try to dodge my chain. Well then fork you, let me explain. Well then fork you, let me explain. Coin is the file and the file is the coin. It's a coin is the file and the file is the coin. It's a coin is the file and the file is the coin. It's a coin is the file and the file is the file is the coin is the file and the file is the coin. It's a coin is the file and the file is the coin. It's a coin is the file and the file is the coin. It's a coin is the coin is the coin is the coin.
Hey everyone, great to see you. It's really exciting to be here with you for day two. I'm looking forward to looking at what's coming next in Filecoin this year. So one second, I'm not getting my screen. One second. Can we get the screen up? There we go. All right, let's get started. Let's look ahead to year two. Again, happy 1 year anniversary to the entire Filecoin network. It's awesome to be celebrating this huge milestone together. This has been a phenomenal week with tons of activity going on across the entire ecosystem, across many countries, tons of meetups going on around the world, tons of different sessions. A huge thank you to all of the organizers that put this together. This is a huge endeavor to pull together a conference of this magnitude. So huge thank you to everybody who created these spaces for the community to gather. And we have a phenomenal lineup for you today. There's a ton of amazing conversations, so be sure to check the schedule and flip around between the stages and go to the talks that you find most interesting. What I'll do today here is just go through some of the exciting things that we can look ahead to in this year. As a reminder, Filecoin is a crypto-powered storage network. It's the storage network of Web3, and its mission is to create a decentralized, efficient, and robust foundation for humanity's information. The Filecoin network is a combination of different subsystems and modules. It involves a blockchain, a protocol, and a network, and a decentralized market that forms a storage cloud. It has a whole app platform, a decentralized economy, and a large and growing ecosystem providing an open service. There are many different parts to this whole picture, and a lot of different people are building this whole network. So one of the things I wanted to start with is yesterday, Molly gave a talk that looked through Filecoin at mainnet liftoff and then looked at Filecoin now and went through a bunch of different features. So what we have achieved in the last year, this is a huge celebration of the tech difference. At the very beginning of the year, we had about 6.6 exabytes. Now we have about 12. So we have greatly increased the network storage capacity. We have greatly increased the chain bandwidth. We've greatly increased the network security now with 3 implementations on mainnet. Really fantastic to see these come online. We've delivered a ton of upgrades, network upgrades in this time frame, bringing in lots of changes suggested by many people around the network. And we've also managed to drop the storage cost of the network to mostly free, especially with Filecoin Plus. So we have this amazing condition right now in the Filecoin network where you can basically store vast amounts of data for long-term deals. This could be like 3, 4, 5-year deals, mostly free. So this is a kind of really fantastic position for all of the people coming into the Filecoin network at the moment. Make sure to take advantage of this awesome deal. In this time period, we've also created a ton of interfaces and applications to help onboard lots of developers, many different vertical use case specific websites and so on that are helping onboard lots of data into the network. There's a ton of cross-chain integrations, hundreds of applications and tools, and there's a massive ecosystem momentum with 10,000 developers, many hundreds of projects and organizations, and at least 60 new startups building on the network. And one of the most important achievements, and one of the things that we're going to be focusing in for the next year, is the fraction of useful storage, and just the sheer amount of that has greatly increased in this period. Now storing 6.5 million NFTs and 30 petabytes of storage. This is by far the largest storage network in the centralized world, and it is starting to contend with a centralized storage network. So this is a really great future for Filecoin, really fantastic achievement. Everybody should feel really proud of getting here. So what's next? Let's look ahead to a few different areas of development that I think are super interesting. And I want to kind of go through a bunch of things that I'm personally super excited about, and I think a lot of people around the network will find interesting. So first and foremost, let's scale the client usage. So that's one of the big things that lots of people are going to be focused on, is to greatly increase the amount of clients using the network. And this involves all kinds of onboarding through different developer on-ramps, making new developer on-ramps, helping many different groups have a great success story, helping people figure out how to use the software, writing new better documentation, improving the UX, and so on. This might also involve creating more use specific tools for different verticals. So again, either developer tooling or developer platforms, or specific consumer-oriented applications that tune to some specific use case, like the personal storage use case. Or we'll start to see some other specific things, so things like photo storage and whatnot. In this time period, we're going to be onboarding a huge amount of data into Filecoin. I hear this about on the order of 200 petabytes waiting to come online of client data that is starting to onboard into the network, with about 600 plus organizations getting started with Filecoin, trying it out, running pilots, and getting going. So this is a vast amount of data coming online. It's going to be a huge endeavor to bringing it on onto the network. In this time here, I think we'll also be making a ton of super interesting consumer storage products. So like chain save files or space.storage, we'll probably see more applications like this crop up. I have two requests out there for people building applications. One would be a tool to back up, to fill kind of the personal backup stories. So think of things like Carbonite and so on, being able to just back up your personal devices and so on to Filecoin. And the other is a photos application. It would be really great to be able to start to store photo galleries and be able to do sharing to friends and so on with a product sort of tuned for personal photos and whatnot. That's a huge one of the things that people want cloud storage for in their personal lives is storing photos and videos and sharing them with friends and family and whatnot. And it would be fantastic to see that develop either as an extension and a feature in some of the applications like chain save files and space.storage, or it could be a dedicated application on its own. I think in the time period, we'll also be storing tons of developer artifacts on GitHub. So this might be package manager registries, containers, VMs, and so on. Special shout out to Valis, who's creating a whole set of tools to be able to publish all kinds of different software artifacts directly onto IPFS and Filecoin. I think it would be fantastic to be able to look back either a year from now or 2 years from now and just see a huge fraction of all of the tooling that developers use leverage the free storage on Filecoin and the free distribution. Let's connect to all of the other chains. So we have a fantastic momentum building integrations and bridges to a number of other blockchains. Let's keep that up and really connect to all the groups and enable them to be able to leverage Filecoin and leverage the useful storage primitives and so on. And this will get even more interesting and more powerful for them once computation arrives on the network. I think one thing that a lot of people are waiting for and working hard towards building is the retrieval market. So I think in this year we can make as a community build, create a huge effort to ship the retrieval market, get it all working, and bring online the CDN style capabilities of the network so that we can get really fast retrieval and we can have high bandwidth to all users and so on. Let's make storage providing easier. So right now it's still pretty difficult to be a storage provider. It would be fantastic to drop the difficulty of that, and that'll be a combination of a ton of R&D in the protocol layer and in the crypto algorithms layer, or in the writing of proofs and so on. In other cases, it'll be changing of actors in the chain and whatnot. And in a lot of times, it'll be just facilities and other systems around the network, or financial services, or other kinds of systems to be able to help storage providers get started, learn about the systems and so on. A huge shout out to groups like Secure Finance and others who are working pretty hard to create good financial services for mining groups. One of the huge things that a lot of us are really passionate about is to make Filecoin green. The Filecoin Green project is getting off the ground, and it has a phenomenal vision and lots of ambitious goals. It'd be really amazing to be able to look back a year from now and ideally at that point be carbon neutral, and ideally carbon negative. That would be a fantastic achievement. That's a really ambitious goal. Let's try to make it and go from there. And it's useful to, as a reminder for everybody, we're still in stage one of the network development and economy development. So let's focus on improving all the different factors there and making it towards stage two. There's still kind of the network's just 1 year old, right? So it's still a baby network in its infancy in terms of its capabilities being fleshed out, feature sets being built out, all kinds of user development flows and whatnot. And so I think this is still like a lot of different features and whatnot are coming online. So many development groups are working on those. Many storage providers are working on those. Let's keep at it and keep improving the quality across the board. Something that I'd love to be able to see is to make the Filecoin economy much more self-reliant. So this means in the sort of export economy view of the Filecoin network, being able to do much more of the activity involved in the production of cloud storage directly within the boundaries of the economy. So this means being able to buy and sell critical goods to storage providing directly in Filecoin. So this might mean hardware like disks, GPUs, computers, data center equipment, all of that kind of stuff. And it might also mean critical services for providers and developers and researchers and so on, like data center services, electric power, food, rent, banking, and so on. Like all of that kind of infrastructure coming online to support the Filecoin economy will help make the economy itself much stronger and be able to leverage into the advantages of the economy to increase to make the import-export model of the economy gave a lot of advantages to all the different participants transacting and trading with the rest of the world. One thing that a lot of us have been waiting for with bated breath is the ability to use smart contracts directly on Filecoin and be able to start adding user-defined applications. We've always had it as a long-term plan to be able to do this. Finally, the time is now. The talk right after mine from Raul will introduce the Filecoin virtual machine to you. Really exciting to see that now that we've built out the storage layer, we can start introducing different kinds of computation on top. And not only computation in terms of smart contracts directly on the chain and affecting state on the chain, but also computation over the data. So one of the big goals for the network is to be able to facilitate computation over users' data stored on Filecoin. So this might mean being able to do schedule jobs or run functions around the data that some particular source provider is storing. There's a lot of different structures for doing this. Many different computation models. We'll build towards that, and we'll build upon we need the computation layer of on-chain user-defined smart contracts to be able to get there. One really massive effort is going to be to be able to scale the chain state and the computation that the Filecoin network can do. Right now, we're already we've already seen the limits of blockchain bandwidth and so on, and we know that we need to be able to hit in order to be able to use Filecoin and blockchain networks to power the large-scale infrastructure of the world. Networks like this need to be able to deal with internet-level workloads, and this means massive amounts of transactional throughput. So I think that the Filecoin network should set as a goal not to get to just a few 100,000 transactions per second, but billions of transactions per second or trillions of transactions per second eventually, and to be able to offer fast local finality. So this means being able to clear transactions within a city or within a data center much faster than the finality in around the world. So this is a huge, ambitious endeavor, of course. Lots of different blockchain networks are working towards this, and this will be a large group effort. I'll plug Marco's talk later today that talks about the strategy that the various different development groups around Filecoin are thinking about to get here. I'm super excited to see the world of NFTs transition into virtual worlds around blockchain networks. And so one of the next big leaps will be to be able to store full virtual worlds directly on Filecoin. So it would be fantastic to be able to work with these groups to bring the storage online. And there are many other groups getting started, so it would be great to work with them. And one other really important development that's happening around the world is that the metaverse is coming online. So through all of these different fractions of interactivity here and there, we're starting to piece together different experiences and high quality environments that are forming the metaverse, and the protocol layers connecting these environments and allowing participants to navigate between them or transact between them and so on are all coming online. So we're getting started on the metaverse. That's going to take, of course, many months and years to really flesh out. But it's already really amazing to see the kind of things that people are building. A huge shout out to the different groups building museums and galleries to be able to showcase 2D and 3D NFTs. I think that's where it starts. That's where the metaverse is being born. And also a huge shout out to the Mona team and who's running the Filecoin Forum build out competition, which is producing just really fantastic, amazing 3D environments. So perhaps maybe in a year we'll be getting together in the Filecoin Forum and having this conversation live in a 3D space. And of course, naturally, we'll lean into scaling the builder funnel to many more projects and startups. Hundreds of groups are getting help and support and are being able to take their projects from early hacks all the way into building businesses. It'll be great to see this scaled out to many more hundreds of projects and startups. And so let's continue growing the Filecoin ecosystem. We're in a fantastic breakout trajectory. Let's keep it going. Let's grow a lot more. And I can't wait to see what everybody builds. It's going to be a fantastic year. And one last note, if you aren't working in the team yet, and you're just an individual around the Filecoin network, or you're just thinking of getting started, there are tons of teams that are hiring right now. This is most of the teams that I talk to are growing. So join a team, get started, and help us build the future. I'll leave you with some advice, which is remember to think long term. These things, what we do now will help shape the future. So remember that the components that you introduce into your systems and software applications today are going to impact how people think and use technology in the future. So remember to kind of build the right thing, and to be resilient. All kinds of challenges will arrive, and so on. Let's create a super resilient network, deal with those challenges as we go as a group, and do what's best for everyone. And now I'll pass it over to what I think is one of the most important things happening this entire week. I'll hand it off to Raul to introduce the Filecoin virtual machine and all of the really exciting plans we have there. Thank you.
All right, so welcome to day 2 of Filecoin Orbit. I'm tremendously excited to be sharing this 1-year anniversary with the Filecoin ecosystem. My name is Raul Kripalani, and I've been at Protocol Labs for 3.5 years, where I've been tech leading projects like Libby2P, Testground, and several Filecoin initiatives. My latest focus these days is the Filecoin virtual machine, and this is what I'm here to talk to you all about. So today, the Filecoin network is a storage and retrieval-centric network. We can think of these two primitives as together being the layer 0 of the stack. And today, Filecoin is able to provide reliable storage and retrieval for humanity's most valuable data. And you've heard it many times before all throughout this event, but the Filecoin network is currently providing 12 exabytes of data and capacity being offered by 3,400 and more storage providers. But storage is only the start. The goal of the FVM, which is what we're introducing today and announcing to the world, is to enable users to deploy their own smart contracts on the Filecoin blockchain. We call them actors in the Filecoin programming model. And this introduces the ability to perform on-chain computation or computation over state, which can be thought as sort of like resolving the layer 1 of the Filecoin capability stack. Once you have layer 0, which is storage, and you have layer 1, which is computation over state, so this is on-chain computation, there are many new downstream use cases that can emerge either on-chain or also off-chain. And those off-chain use cases are what we call layer 2 use cases. And those are things like computation over data. I'm going to go into more detail in the next slides. Now, this slide just illustrates some of the most powerful use cases that the FVM can enable. And these are use cases that I'm personally very excited about. These are things like data DAOs, the Dataverse, and tokenized data sets, NFTs minted, exchanged, and stored under a single roof under the Filecoin network. Things like replication workers. Imagine anybody should be able to write a new smart contract that makes new deals to maintain a specific level of replication of a specific data set or data being added to the network by a given client. Things like trustless reputation systems or storage bounties and auction mechanisms. If you're familiar with Filecoin today, you know that clients have to find providers to store their data with. But imagine inverting that process such that clients post bounties and have providers compete for storing that data. Those use cases are currently not possible, but will be possible with the FVM and layer 1. things like futures and derivatives on storage that compose in a DeFi-like fashion, or things like, for example, conditional loans to providers for sector pledging, or time-locked retrieval, perpetual storage, you name it. There are so many things that can be built on the FEM that we're so excited about. And we really want to get you thinking about the possibilities here. Now, if you think about it, use cases like these are actually hard, if not impossible, to build with centralized and cloud storage solutions. And this is where Filecoin and the FEM are really going to shine. I'm going to deep dive into some of these use cases in the next slides. Dataverse and data DAOs. Imagine kickstarting the dataset economy by tokenizing datasets in order to capture and represent the value of those datasets to society. Imagine if those tokens were harvested and exchanged between peers to request things like computation to be performed on that data. Things like, for example, validation or transformations, feature detection and extraction, machine learning, analysis, and a lot more. Now, chain these processes together and you will end up compounding the value and augmenting the value of those data sets iteratively. And just to top it all up, imagine deploying self-governing entities on-chain to steward, maintain, curate, preserve those data sets that are really valuable to humanity. And like potentially those data DAOs could be funded by crowdfunding. So this is one of the use cases that I'm personally really excited about to see happen with the FEM. Another use case that is very interesting is replication workers. So imagine being able to write actors or smart contracts that take one piece of data and make sure that it's replicated n times across the network, and obeying and using a user-defined policy that specifies things like the region selection or the latency, price, or other things, other characteristics. Now, this thing would actually solve a pain point present today in the network, where clients, if they want to store n copies of a piece of data with a number of providers, they have to perform the data transfer of that data to every single provider. So this would basically offload the cost of that data transfer to somebody that is to an actor that is being incentivized for it in a trustless manner. Another really exciting thing is the ability to have layer 2 systems commit onto the layer 1 of the Filecoin blockchain. And this provides consensus-backed commitment and provability facilities for solutions like bridges, such as, for example, Textile bridges and other bridges that have been built with the Flow blockchain, with Near, with the Ethereum blockchain, Polygon, and a lot more, who are currently operating without a layer 1 commitment on the Filecoin network. So kudos to them. But really, to make this whole process end-to-end provable and traceable, having a layer 1 medium where layer 2s can commit to is extremely important. Another set of use cases that I'm very excited about is bringing richer functionality to storage market, such as, for example, auto-renewing deals, the ability to renew deals without repeating data transfers over and over again when deals expire, when deals get slashed, self-repairing deals. So say, for example, a provider has sectors that fail and they want to recover that data. Instead of having clients send that data over to them again, they could harness those replication workers to have that data sent back to them again and the sector restored. Things like, for example, retrying deals, where clients dispatch their deal data to a depot and pay a small fee to have the deal data be transmitted, satisfactorily delivered to the provider. Things like time-locked retrieval, making storage deals with data that cannot be retrieved by anyone until a specific window of time elapses, trustless reputation systems with so many providers in the Filecoin network. How do you pick the ones that you want to deal with based on the quality of service, guarantees, performance, latency, region? There are already a bunch of solutions in the ecosystem, but imagine being able to build a overlay network of nodes that are patrolling the network, performing observations and recording them on the blockchain so that reputational scores can be calculated in a trustless manner. And also they can be traced and disputable if there is any disagreement. Now, another use case that is super, super exciting, and you can hear more about this use case later on in a talk by Porcucoin, is decentralized verifiable computation. So really, once you start adding computation onto the Filecoin blockchain, you end up in a place where you have both computation and storage under a single roof. And I think that is one of the strengths and differentiators of the Filecoin network. Imagine being able to define a computation to be applied on data, incentivizing its execution all the way to the end, and being able to certify that the result and the output is verifiably correct. And link all of that with the concepts that I just mentioned earlier about the Dataverse, about tokenization of data sets, and suddenly you're in a whirlwind of computation that is pushed to the edges, that is pushed to the providers that have that data, and with an incentivization circuit and a provability circuit with which you can verify that the results are correct. So really, there are boundless opportunities for innovation that layer one programmability is going to unleash in Filecoin. And the Filecoin community is super creative. They have just made it evident in the last year, and you've seen everything that has been presented in Filecoin Orbit so far. So I'm pretty sure that there'll be no shortage of ideas hitting mainnet very soon after the FEM launches. Now, let me talk a little bit about this thing that is going to make all of this on-chain innovation possible. This is the Filecoin virtual machine, and this is the technical part of the talk. I would love to cover this in a lot more detail, but I don't have a lot of time today. But the good news is that you can find a lot of this information in the FEM entry point repo, which I've just linked on that slide. Want to give a huge shout out to community members such as Steb, Stebalian, XSpeed, Boris Mann, Aaron Chick, and many others that have been contributing over the last few weeks to refine these discussions and to refine and to define the architecture and design of the Filecoin virtual machine. Now, just to give you a little bit of history, the Filecoin virtual machine and the layer one programmability has been in the roadmap for a very long time, and it was rekindled by FIB discussion 113. If you want to go into it, take a read, understand how things got kickstarted again or resumed again. The thing that got us really prompted to prioritize this work now is the overwhelming positive reaction to this FIB from developers, storage providers, ecosystem partners, and a lot more. This got us incredibly motivated and made us jump right into action to make it happen for the Filecoin community. Now, as I said before, the user programmability had always been part of the roadmap in Filecoin since the very beginning, but the road to get where we are today wasn't easy. Filecoin had been in development for 6 years prior to mainnet launch, and just to build a secure and permissionless decentralized storage network, we had to solve fundamental challenges and limitations that led to important breakthroughs, things like proof of spacetime, proof of replication, expected consensus, unbiasable randomness, ZK SNARK applications, and a lot more. And at that time, it wasn't clear what the future of blockchain VMs was going to look like. Was there a standard emerging with the EVM? Was this kind of like the silver bullet? Was Wasm, this new kid on the block that was receiving a lot of attention and traction, going to be the thing? There was also secure ECMAScript that was being proposed, LLVM IR, some blockchains were looking into that. So during that time, we decided to focus on layer 0, the storage and retrieval layer, and to kind of like wait it out to see where the VM ecosystem trended towards and consolidated towards. Now, just to give you a little bit of a few light touches on what the inspiration of the design of the Filecoin VM has been. There are several key concepts here. The virtual machine hypervisor model inspires the architecture of the FEM, and like hypervisors, containerization are two concepts that inspire the architecture, and the ability to host multiple runtimes in an isolated manner over a common base layer. Another concept from computing that really resonates with us, and like I think this is really where we strongly think that this is where blockchain computation will go in the future, is the actor model. And concretely, Erlang OTP as a runtime is a paradigm that inspires us. We particularly like the functional approach, the self-healing mechanisms, the location transparency, and the messaging model, which are great concurrency primitives to build parallelizable computation on blockchains over time. Now, just to give you an overview of the technical design of the FEM is fundamentally based on WebAssembly. We looked at other things like LLVM, IR, the JVM, secure JavaScript, and secure ECMAScript, and other options for the core layer of the FEM, and ended up settling on Wasm. For those who are not familiar with Wasm, it is a portable execution format that initially was built for the web and in theory meant to replace JavaScript, but which has transcended to other runtimes. And it has seen a massive traction and uptake in blockchain ecosystems. So we believe that joining this traction and joining this community will also help speed things up and solidify things together as a blockchain community with other members and other partners. Now, one key aspect of the FEM is that one thing that it should do is interact with IPLD state tree data efficiently. And we're putting a lot of attention to this. Now, native actors can be written in languages that compile to Wasm. This doesn't mean that you want to use any language that compiles to Wasm, because you do have to be aware of the runtime costs of certain languages and the overheads of certain languages. One language that we think produces really succinct and nice Wasm is Rust. So we're building the SDK, the reference SDK in Rust. And one key aspect of the FEM is that it has support for foreign runtimes, foreign VMs, such as the EVM, and eventually the Agoric S potentially, LLVM IR, BPF, and other virtual machine models. Now, the thing that I wanted to stress is that we're trying really hard to launch the FEM with EVM compatibility out of the box. We've heard strong requests from the Filecoin developer community for the FEM to support EVM and Solidity compatibility out of the box. So we made this a priority. With the FEM, developers will be able to deploy Ethereum smart contracts to the Filecoin blockchain directly. And this makes a lot of sense because the Ethereum community has amassed a massive corpus of useful and, most importantly, audited and battle-tested smart contracts over time. Like, for example, ERC20 tokens, NFTs, DAOs, flash loans, you name it. So having the ability to take these contracts and deploy them as is to the Filecoin blockchain is a great onboarding ramp for developers that are already familiar and trust those contracts. Now, the Ethereum ecosystem has amazing developer tools like Truffle, Remix, Hardhat, plugins for IDEs, and a lot more. And also, Solidity has become the de facto smart contract programming language that smart contract developers out there basically master. So this facilitates their onboarding into the Filecoin ecosystem. Now, just to give you a little bit of a technical view on how we plan to make this happen, the plan is to adopt an EVM bytecode and Wasm approach instead of working off Solidity directly. This choice guarantees almost perfect execution, fidelity, and parity, and mitigate risks otherwise present in the Solidity to Wasm compilation path. We concretely looking at adopting the Sputnik VM project, which has emerged as the de facto Wasm compatible EVM implementation in the industry. And it was initially developed by the folks at Parity, but it's also been adopted by the blockchains like Near in Project Aurora. We still have many difficulties to solve around the mapping between the EVM and the FEM models, things like the memory and storage model in IPLD, gas accounting, calling conventions, representing events and logs, but we're confident that we'll figure this out, and also with your help. So please make sure that you join the discussion to help build this out. Now, a few touches on the data layer itself. We can consider the FEM a computation engine for IPLD data. The Filecoin state tree and the actor states are IPLD objects. And the FEM essentially executes computation on those inputs to produce outputs. So building libraries and primitives to interact with IPLD data must be a core priority, and it deserves a lot of attention. We're also looking at implementing an IPLD-based interface description language to describe actor interfaces. So you can think of this as kind of like the SOAP, the WSDL and SOAP, or the IDL and gRPC for on-chain actors, which will then power tools to generate clients for cross-actor calls. It is also worth mentioning that this VM isn't directly tied to and tightly coupled to Filecoin, and it can be adopted in other contexts, such as IPFS and IPLD itself. If you're interested in the nitty-gritty details of how all of this will work, I totally encourage you to check out Step's talk later today, which is on IPLD and Wasm. Now, another thing that I wanted to mention is that user-defined actors will exponentially increase the demand for space in the blockchain, and the significant research going on at Protocol Labs within Consensus Lab, looking into things like sharded and hierarchical consensus with parallel execution. And this has a bunch of implications in the FEM, such as the kinds of calling patterns that will happen depending on whether calls are intra-shard or cross-shard. And you should totally attend Marco's talk later today on consensus scaling and sharding for the Filecoin network. Now, if you want to, I've just kind of given a few light touches on the technical design of the FEM. If you want to learn a lot more, then you can go into that repo, explore the docs, and contribute. There's a lot more detail in the technical documentation in that repo. Now, onto the part that I guess most people are interested in, which is when will this ship? We've got into that part. All right, so the roadmap consists of 4 phases. Phase 0 is to have the FEM implemented, running the built-in system actors and having canary deployments of various clients, Filecoin clients on mainnet, running a non-programmable FEM, and we expect to have this done by the end of this year. All of these timelines are very tentative. Phase 1 will introduce changes to the network to prepare the network for user programmability, and this will happen in Q1, by the end of Q1 in 2022, we believe. Phase 2 will be all about launching user programmability proper with native actors and EVM foreign actors. And the goal here is to really enable user programmability. And we think that this will happen sometime in Q2 2022. And in phase 3, we'll redesign the system actors for improved programmability against them. And this is also going to ship around Q2 2022. There are still many unknowns here, so these timelines might change in reality, but hopefully these will be we'll be able to stick to them, and with your help, we'll be able to figure things out as well. So how can you get involved? First of all, if you want to check out the FIP discussion, make sure that would be one thing that I recommend you to do. Next thing is to follow and engage in the Filecoin project FEM repo itself. Another thing that you can do is join the FEM channel on the Filecoin Slack to stay tuned with everything that's happening. If you actually want to get your hands dirty and you want to start designing and building stuff, admittedly, it is still a little bit early, but you can really help out in fleshing out technical detail by helping in the discussions and kind of like participating in the discussions in the FEM repo, where we're investigating all of these uncertainties and kind of like unknowns that we still need to figure out. And of course, one thing that we'll love people to start doing is to start thinking about the use cases that they want to build. And thinking as well about kind of like those base libraries and tools and examples and actor templates that are going to make life easy for everybody in the ecosystem. So we really imagine things like, for example, OpenZeppelin in the Ethereum ecosystem, which is a very nice toolbox library to emerge in the FEM ecosystem. Things like local test sandboxes, test frameworks, deployment tools, IPLD IDL generators, and a lot more. These are things, if you're interested, start talking to us in those forums, in the GitHub repo and in the FEM channel on Slack, and we'll figure things out. Now, before I go, I just wanted to leave you with one thought. The FEM is basically a greenfield ecosystem that is just getting started now with a new programming paradigm. And there is an opportunity to start thinking early on about composability and modularity upfront, drawing inspiration from kind of like, the ERC model in the Ethereum ecosystem and DeFi composability. So really start thinking in terms of Filecoin standard interfaces for reusable primitives that can be composed with one another to create complex actors, things like payment channels, vesting schedules, multi-sigs, and voting mechanisms, loans, and a lot more. We're really, really excited to see what you'll build on the FEM. I hope you're excited, just as excited as us, or even more. And make sure that you stay tuned for things like grants, bounties, and other incentives to kickstart an innovative ecosystem on the FEM and build on the FEM. Thank you so much. Oh, and before I go, I wanted to just plug in a job opening for, in case you're interested in working on the FEM and also in building the future of decentralized computation. Make sure to check out this URL to see what opportunities are open. Thank you very much and have a nice one. Enjoy the rest of day 2 of Filecoin Orbit. Happy 1-year anniversary.
Hey there, I know that you all are glad to see me back for day 2 of Filecoin Orbit, but you're gonna have to wait just a minute. We're going to a very short break and then we're coming back to you with programming. All right, we are back on the exit velocity track where we'll be covering all of the core protocol innovations and upgrades to Filecoin. Today on day 2 of Filecoin Orbit Virtual Summit, we'll have our eyes on the future. What's coming next? On my end, hopefully the end of COVID, but on this track, we'll be looking at Filecoin's future. One crypto housekeeping note, we know you're all sitting on crypto Twitter all day, every day. So if you're struggling to figure out what to post today, I will help. You are here. What about posting about this awesome event using the hashtag FilecoinOrbit? Sounds like a great idea. I already did it, so you can retweet me at BLR13 if you don't want to come up with your own tweet. Shameless plug of my Twitter account as well. Now that that is out of the way, we're kicking off this track with a deep dive into the product that was just announced in that keynote, the Filecoin Virtual Machine, or FVM for short. And for that, we've got Stephen Allen, or as he is also known, Steb Alien, which is an awesome nickname, who is a senior software engineer at Protocol Labs. So, Stephen Allen, tell us all about what the devs can do with the new FVM.
So I'm here today to actually talk about IPLD and Wasm and how we're going to use this to power the FVM, or at least that's the current plan. And also how you can use IPLD and Wasm together in your own systems and why you might want to do that. So this is really going to be about IPLD and Wasm on a blockchain. I couldn't resist using the transition there. I haven't used it in years, so you have to give me for that. But yeah, so if you don't know what IPLD is, I'm going to give you a short introduction here. This isn't going to be too much, so you might need to do some more research by yourself. Okay, what is IPLD? IPLD really is abstraction over arbitrary Merkle trees. So Git is IPLD, IPFS is IPLD, Filecoin is IPLD. It's really any Merkle tree data structure you can understand as IPLD. Really, I just want you to think trees or hash linked trees of data. So whenever you think IPLD, just think, look, you have a sort of a reference to an object, that object references other objects, and you have these trees of objects. Okay. Really, it's all in the CID. That is sort of the magic sauce of IPLD. CID is a content ID or a self-describing content ID. Or like ideally, you think of it as a content pointer. So a CID is actually, it's composed of a codec that describes the CID itself. It says this is a CID, or really a version 1 CID. Then it has another number basically that says, hey, the data that this CID is referring to is of this type. And then finally, it has something we call multi-hash, which is just a self-describing hash function or hash. Now, before we can really understand this, we have to understand what is codec in this case. Codec is actually a multi-codec. It's a separate thing we have. It's just a number. That's all it is. It's just a number in a table that is unique, that we can use to uniquely identify things. Okay, what is a multi-hash? Because remember, I talked about how this has it described, basically the format is the codec that describes it. This is a CID, then something that says what that describes the actual data it's pointing to, and then finally the multi-hash. A multi-hash is just a hash, but it's, again, a self-describing hash. It's a hash digest that also includes information telling you what hash function to use to produce that digest. This just means we can upgrade the hash digest later if we need to. We can also swap out the underlying format of the data later if we need to. But that's the basics of IPLD. If you want to understand more about this, I highly recommend you read the docs or take a tutorial. This is a very short introduction. Thank you. Finally, or second of all, why IPLD? So IPLD is basically the primary reason to use IPLD is that it's content address. Content address means that instead of pointing at it by location, you refer to IPLD objects by the content itself. You describe the object, in this case, using a hash function. This means the data is verifiable. If you give me an IPLD object, I can verify that it matches the address of the data they have, or the CID, without having to trust anyone. It's immutable, which makes it really cache friendly. So if you fetch something, you don't have to fetch it again and again and again, just wondering if it's changed, because it can't change. It's also copy on write, which means that if I have some large IPLD data structure and I change it, you don't need to transfer the entire data structure again and again. Every time a small change is made, you only need to transfer these small pieces that have actually changed. It's also structured and self-describing. So like the structured self-describing nature means, one, we can have tooling. We can have IPLD schemas, which are another form we have for describing data types and stuff like that. We can have standard protocols for transferring this data. We have BitSwap and GraphSync, and you could have standard languages for querying over this type of data. For example, we have selectors, and these different things can actually operate over any type of IPLD data. So they can operate over Git data, they can operate over CBOR, they can operate over Ethereum data even. It also removes ad hoc parsing because, again, it's all structured, so you don't have to think about parsing your language. And finally, the self-describing codecs actually allows us to upgrade and change things later. There are always advances in formats. People decide they want to use something new in the future. If you just say, well, everything's going to be JSON, then the second something new comes along, you're kind of out of luck. With something like IPLD, the codec that describes the format you use is in the CID. So you can just add a new codec, define a new format, and move on. Okay, what is Wasm? this is moving very fast, but Wasm is a format for portable, secure modules. If you're watching this, there's a fairly good chance you've been introduced to this concept. Really, it's a state-of-the-art VM that draws from both the JVM and the LLVM. It's also an instruction set. It's also a module format that describes imports and exports of functions and global variables and memories and all this kind of stuff. It was originally designed for the web with security and isolation in mind, but it was heavily influenced by the needs of blockchains. Ethereum is thinking about using it for the next version. There are a lot of other blockchains that are currently looking into it or actively using it because it's deterministic, and a lot of predictions have like built-in gas accounting and that kind of stuff. Okay, what is IPLD plus Wasm? Really, this is just Wasm modules encoded as IPLD. What this means is you can have a Wasm module that can import other Wasm modules by CID, content ID. It also means that you have IPLD, or you have functions that operate on IPLD data. That is, instead of just taking like an arbitrary set of like numbers or arbitrary data, it would take an input IPLD tree and spit out an IPLD tree. So why IPLD plus Wasm? Well, one, content addressing or content addressed code, which means you can lazily load code. You can also securely use libraries and secure code reuse. You have content addressed data. This means that you can lazily load data. Your data, basically your memory is network transparent because it's all IPLD, so you can just transfer it over our standard IPLD transfer protocols. You can get easy distributed computations where you only need to load move around the data that's changed and that you actually need. You can do this lazily, and you also have general purpose tooling for actually moving the data around and working with it. Finally, because it's all content addressed and immutable, you can memorize results. So if I have the CID or the content ID of the code, the content ID of the inputs, and I've already computed something, I can just cache the outputs and I'm done. Also, you can use data by reference. So this means that I can pass a large immutable tree to some Wasm module or some Wasm function without actually sharing my memory with that function, and without copying all this data back and forth. And that Wasm module can actually just load the data it needs dynamically as necessary, and then return a new CID for its new data structure. This means that modules can cooperate on large data structures without trusting each other. It's also typed and structured, which is just really nice when working with other languages. Okay, why on a blockchain? Well, it's content addressed. Code can be loaded and deployed many times without having to like re-upload the entire code. You just refer to it by CID. Libraries and new contracts can be cheaper to deploy because you don't actually have to like re-upload all of your code. You just need to upload like a little bit of code for your contract. You can use libraries that are just on chain. Yeah, it increases runtime costs a bit, but this can be alleviated in various ways. So I'm not too concerned about that. Second of all, it actually, because you can pass around data by reference, it enables secure delegation. So currently, when you delegate some of the contract, you usually say, okay, you can use my memory, do whatever you want. With IPLD, you can give another function or the contract or whatever access to a specific IPLD tree, let them compute over it, and then get back access, or sorry, get back the new CID, and then you can actually verify that they correctly did the operation on this data. You can also have bulk access. So if someone asks you for some of your state, you can just give them reference to basically an entire subset of your state, and they can sort of write through it as they need to, rather than having you just call back in and ask for more and more data every single time. So it can reduce gas costs. It's also, again, typed and structured. This means you can have really nice descriptions of your inputs and your outputs for your smart contract APIs, and the actual type information can actually be encoded as IPLD objects, so you can even upload it to the chain or keep it offline if you don't want to pay for that. It also means that the actors will directly manipulate the state tree. So in Ethereum, actors, or sorry, I say actors because we call them in the FVM. In Ethereum, contracts sort of like they just read and write different locations in memory. But this means that like implicitly behind the scenes, everything gets serialized as a Merkle-Patricia tree. In IPLD, like the user would directly manipulate this tree itself. So when the contract is done, everything is done. There's no implicit operation, which means the gas cost can be very accurate. And actors can also optimize their own data layouts for their use cases. Okay, why not IPLD? I always like to mention this just in case, or just to be clear. Like one, there is the cost for serializing and deserializing. So if you're trying to like pass data between different modules, you're going to pay that cost. Second of all, hashing. Hashing can be expensive. We've actually found that it's like modern CPUs are pretty good at this. It's not that bad. And you can also try to avoid as much as possible. Tooling libraries, IPLD is still growing. There's still a lot of work. And finally, abstractions. IPLD is an abstraction, and you will pay for it in terms of complexity, but you get tooling and get all the standards out of it, which is really nice. Thank you. That's it.
All right, cool. That was pretty cool. Thanks so much, Stephen. I wish I was a developer so I could play around with this as well. Maybe if I ever get a break from events, I will learn to code. Send me the best how to code classes in the Open chat, please. Up next, we have a talk about VDFs and Metaproof, which are projects out of the Crypto Compute Lab. All right, take it away.
Hey, my name is Chima Kunzung. I'm a software engineer at Protocol Labs, and today I will be giving a brief survey of some projects spanning diverse domains linked by common threads of research and development. This is really at least two talks squished into one, so I decided to try to highlight the themes which connect all of this work. I'm going to have to move fast to get through it all, so I apologize for what will necessarily be a superficial treatment. I work in a team called Crypto Compute Lab. We implemented the Filecoin proofs and have continued to maintain and improve them. However, in the years since Filecoin mainnet launched, we've also turned our gaze to the horizon. Today, I will present a few of our longer-term projects which span low-level optimizations, high-level abstractions, hardware manufacturing, and prospective cryptographic systems that are literally out of this world. Okay, so the first topic is VDFs. VDF stands for Verifiable Delay Function. And some of you might know this. This might be new to others. But a VDF is a function that is slow to compute and fast to verify. And we can use it to ensure that a minimum time has passed. So, for example, if we have function f of an input x with a time parameter t, then y is going to depend on x and take at least time t to compute. And to get an intuition for fast verification, we mean even if t is high, like 100 years, verification time should remain low, like milliseconds. Okay, so what's an example of a usage of a VDF? On a blockchain, you might want to prevent grinding on deterministic pseudo-randomness. So if the chain is going to compute a random number based on a public value that the user can influence, the user might try to brute force that and get a good random number, whatever that means. So we can stop that by making it take some time for the randomness to be computed so that the user isn't going to know whether their number is good or not until it's too late to try to change it. Another example comes from the Filecoin domain. If you're familiar with the proof of space-time, one thing we could potentially do is let storage providers perform their post on regular intervals, but only submit those proofs less often in order to minimize the chain bandwidth. But the problem is we need to be able to prove that the post happened at the right time. The attack is that the provider actually throws away their data and regenerates it, and they do all their posts all at the same time right before submission. So if we have a VDF, we can separate those posts and make sure that a fixed time passes between each one. But this actually requires a very good VDF, whatever that means, which we'll talk about a little more later. Okay, so this is the slide with a lot of information about a computational VDF. You might have to just look at it and see what you can make of it. The main point is that a forward direction evaluation, which you can see in my diagram here, is slow because exponentiation to a large power requires many multiplication operations, which your computer has to do. But the inverse direction is fast because the return trip is shorter in a finite field where we have modular arithmetic. This is an oversimplification of the min-root algorithm, but it's generally what we use. There's something called the AMAX, which stands for Attacker's Maximum Advantage, which is an important concept with VDF. Important general concept with VDFs, which is basically how much faster can an attacker compute this function than an honest party who's using the regular function that everyone's supposed to use. And the lower we can make that, the better. So we're working with a company called Supranational, and they have made an optimized CPU evaluator already, but we need to go even faster to bring that AMAX down more. So part of this work is to design and build an ASIC. The better our ASIC can be, the more an attacker is going to have to spend to try to get an even better ASIC. So this is the hardware computation-based approach. The limitation of this is that even the best hardware VDF we could possibly build is not going to be actually optimal. Hardware is always getting faster. So we're not going to get an AMAX that is practically 1. And unfortunately, that's what we would need for this Filecoin example that I gave this periodic post. This is where the idea of a latency-based VDF comes in. If we want to get an AMAX that's practically 1, we need some kind of a hard speed limit we can actually reach. So how about the speed of light? So we're working with a company called CryptoSat, and we're investigating the idea of a space VDF, where we would have secure satellites placed in publicly known positions. NORAD tracks this, so it's fairly discoverable whether they really are where they're supposed to be. They'll generate private keys in space, and as long as those aren't leaked, then the physical locations of the signatures that they make will be known, so we can establish a minimum time between sequential signatures. So we're in the early stages of this, but CryptoSat is conducting a system-level trade study to figure out which parts of this are actually viable and how it would work, so we can actually do some Filecoin orbit stuff. We talk a lot about the space metaphor, but here's an actual space project, which is fun. So how do we do these proofs? Verifying one step is always fast, like I showed you before, whether it's a small exponentiation or verifying a message signature. But when we want to make many steps, we need to for a long delay, these things are still stacking up. So we can use a SNARK and prove many steps at the same time. But it still doesn't solve the general problem. And the general problem is that whatever the actual rate, the proof size and verification time are still going to scale linearly with the delay time. So can we snark the SNARK? The historical answer to that is, well, it's not quite so simple. That is a complicated thing to do. But nowadays, it turns out, yes, we can use recursive SNARKs. I drew a picture here that gives you some kind of an idea of what that might mean, but we don't have time to talk about it in detail. So we'll just move on. So this is it. We are building hardware and software optimizations for recursive proving systems. We're working with the Electric Coin Company, who you might know from Zcash. And we're also using Nova, which is a proving system coming out of Microsoft Research. So Halo 2 and Nova are two candidate proving systems. They both use recursive SNARKs. They both work with the pasta curves, and they use different arithmetizations for the constraint systems. Either way, we're working on CPU optimizations for verification, GPU optimizations for off-the-shelf proving, and ASICs tuned for proving on these things. And the goal is to make creating recursive SNARKs 5 to 10 times cheaper. So this should be good for everybody. And that brings us to metaproof. So metaproof is a crypto compute lab project founded on our frustrations with the limitations of previous generation SNARK techniques that we had available to us when building Filecoin. With modern proving systems on the cusp of accessible recursion, we saw an opportunity to leap forward, and metaproof is our vision for how to do that. So we want to decouple the proof specification from the underlying proving systems. Like, we don't write most of our software in assembly or logic gates, so why do we write our proofs that way? We want to write proofs that can be deployed to multiple proving systems like Nova and Halo 2. We want to have proofs that are about proofs so that we can use the proving mechanism to help us know that our programs are correct. How do we know that our circuits are actually doing what we want them to do? This is hard to do. And we want to support general computation, especially in the domains of decentralized data. So writing proofs should feel like writing programs, and that's one of our goals. So recursion actually makes this possible. And we are going to build Turing complete SNARKs via recursion. What does that mean? So the traditional SNARKs like Filecoin has today are bounded. We have a circuit and we can only perform a certain number of calculations in each circuit. In Filecoin, we raised that limit to be very large, but at the end of the day, this influences the form of the computation we can actually perform. So we can't have unbounded loops, we can't have arbitrary control flow, we can't have unbounded recursion. And this makes it hard for us to write things that feel like normal computer programs, and puts us in a box in terms of the kinds of proofs and protocols that we can design. So Turing complete SNARKs overcome these limitations, and everything that was, a no on the left side is a yes on the right side. So we'll have unbounded arbitrary control flow and unbounded recursion. Okay, so we have a Turing complete SNARK language in development. We call it LURK, and there's a lot to say about it, but there's not really time here to do it justice. So we're going to open up this project hopefully by the end of the year, and at that point you'll be able to use this language to generate and verify proofs, and you'll see end-to-end examples with running code. Meanwhile, we can tell you that LURK has a small core that implements a minimal Lisp. You can use that to evaluate arbitrary programs. Programs are data and vice versa, and the data is content addressable for compatibility with IPLD, IPFS. So there are a lot of approaches to Turing complete SNARKs. What we're doing is just one of many exciting things that a lot of groups are doing, but we're especially focused on the use cases that fit with Filecoin and Protocol Labs is decentralized data centric applications. So hopefully we'll have that available by the end of the year. You can check out the repo and ask us questions there if you want to. And just to give you a sense of what this looks like and what's interesting about it, this is a slide that I took from more detailed presentation, but I'm including it here because it shows a very small, self-contained and complete example. So this lets you see what the code looks like, and it also provides a minimal example of something that Turing complete SNARKs allow, but that is impossible with ordinary SNARKs. So specifically, this example allows me to prove both membership and non-membership of an element in a set of unbounded size. And the prover cost is linear in the actual size of the set. So there's a lot to unpack here, but if you can understand this example, you'll see many of Lerk's interesting characteristics. The main thing is if you're not used to thinking this way, and you happen to be able to read Lisp code, then this just looks like a short Lisp program that's inspecting some data. And in fact, that's what it is, and that's what's interesting. And so the Lisp data is the same form as Lisp code, which is this content addressable, SNARK friendly IPLD. Like I said, a lot to unpack, but it's very exciting for us, me at least. So hopefully over time, we'll see the fruit of this. So Lerk is very expressive and legible, as you saw before. You might take issue with that if you don't like the way Lisp code looks, but it's also a natural target for other languages. So if you don't like that, build something else and compile down to it. We already have a number of projects that are either starting work on or planning to develop backends for Lerk. There's a lot of information here, so you might just want to read these slides. I'll talk over it a little bit, but we have Yatima, who's working on a Lean4 theorem prover kernel that integrates with IPFS and IPLD and will compile to Lerk. Nada Amin is a programming languages professor at Harvard, and she's working on relational programming languages on top of Lerk. And in fact, she's implemented already the core functional part of a language called microconren. And it only takes a little bit of code to do this in Lerk, which is neat. So she's looking to develop a relational layer on top of Lerk. There's an internal PL project called Verily, which is working on certifiable IPLD data and transformation for decentralized systems. And we're looking at targeting Lerk for that as well. And we're also working with a language called Glow for decentralized applications. That's a very close fit to have a zero knowledge proof backend for their programming model. And we have a first Filecoin specific application in mind for this. And this is verifiable computation over Filecoin sectors, which I think is super exciting. So Filecoin makes it cheap to store a lot of data, but what if you want to operate on that data without retrieving all of it? I don't want to have to transfer 32 gigabyte chunks of data every time I want to perform some kind of a query on my data. So let's say I have a database containing millions of weather records, and I want to know the average temperature in Lisbon on days in 2020 when it also rained. A storage provider could calculate this small result and return it along with a proof of correctness. And if that's verified on chain, this is going to allow smart contracts to interact with sector storage. So for decentralized computation to be efficient, it must be possible to eliminate redundant computation and co-locate the storage and computation. And this is going to let us do that. It's very early, but this is probably the most exciting application for me because it builds on Filecoin. So we're looking forward to working with the Filecoin virtual machine team, FVM team, to explore these possibilities and see what kind of interactions will be possible. So in review, we're working on VDFs with optimized hardware and software, and we're putting satellites in space. And through that investigation of space and time, we were driven to investigate, support, and help develop recursive SNARKs. And this allows Turing completeness. So we developed a programming language that exploits that. And this lets us do many cool things, many of which we don't even know yet. But one of them is verifiable computation on decentralized data in Filecoin. So watch this space. The work is only beginning, but it's very exciting. Thanks for listening. These are all my closing parentheses. It's a Lisp joke. Thank you.
Awesome. Thank you so much. All right, everybody who is watching out there, the exit velocity track. I had mentioned that you all should tweet about this conference with the hashtag Filecoin Orbit. And, I have 0 new followers at BLR13. So you have not been listening. Go follow me and also retweet what I've tweeted about Filecoin Orbit, hashtag all the great stuff that's happening here. All right. Again, thanks so much for that last talk. And up next, we have a talk called What's Under the Textile Bridge? And it is not a troll. No, in this session, led by Textile CEO Andrew Hill, he's going to dig into the architecture of the bridge that has allowed many blockchains to seamlessly integrate into the Filecoin ecosystem. So Andrew, I'll throw it over to you.
Hello, everybody. Thanks for having me. This is such an exciting lineup to be involved with. So many cool updates coming out from the FDM and LURK, like really awesome. And Textile's been watching a lot of this very closely and trying to think, what can we do in this space to really help move this forward? And so today's talk is called What's Under the Bridge? Some of you may be wondering what bridge we're talking about. And so I wanted to give that to you just up front, because I'm going to go on a little journey along the side, along a different path to start. So you can find more about the bridge at eth.storage. I'm also going to talk about a concept we've been building that hopefully will lend itself to a lot of what's coming in the VM in the near future, called Filecoin deal auctions. And you can find more about that at this tiny URL. I'll get back to those at the end. But I want to talk about the bigger picture first. Why are we talking about all of this? And for me, the bigger picture really is important because it drives all of Textile's vision and mission and really helps us figure out what we want to be building and who we want to be helping with technology. So I want to start with a little story that I think many people watching probably are familiar with the first part of it. But let's start with Kardashev's scale. So in 1964, Kardashev came up with this idea that we could describe the progress of civilizations in the universe by the amount of energy that they were able to harness. And so he initially just had 3 types of civilizations: a type 1 civilization that's able to harness all the energy that arrives at its host planet. A type 2 civilization is able to harvest all the energy that is emitted from its host star. And a type 3 civilization is one that can harness all the energy of an entire galaxy. And you can see there's something like a billion orders of magnitude between just the last 2. So these scales are huge. Unfortunately, humans aren't even on this scale. There's no type 0 in the initial scale, and we don't harness all the energy of our entire planet yet. So that's interesting, but I think even more interesting is an idea that Carl Sagan came up with, as were most of his ideas. But he said there's another criterion that we could measure civilizations by, and that's the amount of information that they store. And I think what he really meant by store here is have access to. And he said that information could just be described in terms of bits. Or if you're not familiar with how to think in bits, simply a number of yes/no statements that we can use to describe and classify the universe that we know. Okay, so what does it mean to know information? We need to unpack this a little bit so we can arrive at how do we use that to classify and understand the progress of civilization. So what does it mean to really know information? And I think using that yes/no framework really helps here. And so he said store, meaning access to. So knowing information means having access to it. And if we think of it as a series of yes/no questions, we can use the game of 20 questions to frame this and look at how much information we have. So in case you're not familiar, which I'm sure all of you are, a game of 20 questions is just one person has a thing that they think of, and the other people playing have just 20 questions that all have to have a yes/no answer that they need to use those 20 questions to arrive at what that thing is. So let's see it in action, because what's really interesting is that each question that you ask divides the universe into 2 portions, 2 bits. And so as an example, we have this universe of things, and I imagine a thing. Now you want to get to what that thing is. So you ask, is that thing an object? So in that first question, you've created the first bit. Then you might ask, is it biological? If my answer is yes, you move down another path, but you've divided the universe again. And so in just 3 questions, you've divided the universe into 8 possible outcomes, so 8 bits of information. So in 3 questions, 3 yes/no questions, we've created an 8-bit universe. So in the game of 20 questions, so it's 2 to the 20, so just over a million bits of information, and we love base 10, so something like 10 to the 6, roughly. So Carl Sagan said, okay, that's a great starting place to measure the progress of a civilization, 10 to the 6. And he said, let's build a scale from that. Let's start there and say, every time we move up the scale, we'll describe a more advanced civilization on the information scale. So type A civilization, he said, had 10 to the 6 bits of information accessible to it. And then moving up, he arrived at the type H civilization with 10 to the 14 bits. His estimate of how much information 1970s humans had available to them. A more recent estimate on this scale says that humans in 2018 were type J civilization. And so if we multiply that by 1 million, we get to the type Q civilization. So this would be a galactic civilization with the information of 1 million worlds like our own. And so this goes all the way up to type Z, which is something that Carl Sagan posited wouldn't even be possible given the age of the universe yet. But this is really cool. So humans are currently type J civilization. Like working in kind of the startup world, I think, oh, that's so interesting. That's the KPI for humanity. That's the KPI for us as a civilization, is we can track humanity's progress by looking at how much information we have access to. What I think is really interesting when you look at it that way is something's holding us back. And I know something's holding us back, but I don't have a lot that I can show you, but I can give you the same feeling. And that's why I'm telling you this story. So my feeling is that there's something odd going on right now between the information that we create as a civilization and the information we have access to, the key to moving across the scale. So as time has moved forward, our creation of information has really gone exponential, but our access to information has trailed behind that. And that information gap, I think, is what is leading to a lot of uneasiness, especially in technologists today. We're in this period of runaway information creation. So if you think of early days of networks, of computer networks and emails and message creation, that information creation just in your personal life has run away. So it moved to shopping and clicks and behaviors online, your photos. Now you're dating, and your friendships and your relationship preferences and your location and your medical records. And that data is just going up and up and up and up. But the internet economy is fueled by privileged access to that information. And that sort of discrepancy between who is collecting the data and who has access to it is leading to a gap, leading to that information gap. Oh, sorry, I lost an image here. And what's even more interesting there is that discrepancy is snowballing on itself. And so some people have said data has network effects. And the reason that is that as an organization or a government collects more data, they actually are able to gain further insights from it and feed it back in to collecting more data. And so in a sense, data has gravity. The bigger it gets, the more mass it gets, the more gravity it has to collect more data. And we see that even with the creation of data silos in organizations. We see companies be bought entirely for their assets of data. So these closed silos that we're creating in society may be among the most valuable things ever created. And so this fact that data has gravity means that they're going to continue to grow, they're going to continue to become more valuable, and it's very hard to get that back into society's hands. What I think is actually important to point out here, though, is that this collection and organization of data may actually have been a good thing for society over a short period of time. It's led to a number of great innovations in technology, but over a long period of time, this could be very bad. And this can be very bad if we think about our progress through the scales of civilization. And so I'm sorry, Carl, we might be stuck for a while if we're not careful. We may not move as fast through these scales as we would hope to. So how can we fix this? Well, I'm a big believer that one of the first ways that we fix it is with storage. And that's why we're so excited about Filecoin, is it starts with access, it starts with preservation. And decentralized storage offers us the hope that information can truly be made free to all of society. So I can store scientific information that anybody in any country, in any school, in anywhere can access and use to create more information for us as a civilization. So storage and linked data for me are very important. And then it goes to access and collaboration. And so Textile, our mission is to increase the exchange of information across society. This is very intentional wording. Exchange is bidirectional, implies value, it has multi-actors, it has permissions. We think this is actually something that we can measure as a company. We can measure our impact here. And it starts with actually just looking at how much data we can move across peers in the networks that we create. So this brings me back to the point of the talk, what's under the bridge. So I want to show you some concrete pieces that we've been working on and experimenting with that are moving us towards this greater exchange of information for society. What we're imagining is high throughput storage protocols for communities. So rapid I/O, indexing, curation, and compute all on top of Filecoin. If you heard Raul's talk or just the previous talk, these ideas of FVM on Filecoin, they're so exciting for us. And this is what we're building towards. We're building towards the next layer that sits right on top of that and adds the abstractions so that society can build new data silos that are owned by communities and support the needs of DAOs, of games, of networks of creators, of researchers, and more. Let's look at some of the things that we've already built. So one of the experiments that we're doing, which I think will lead right to the FVM when it lands, is actually new deal making on the Filecoin network. So we created an auction system that has stored over 150 terabytes to date on the Filecoin network. This is a simple protocol that makes it so that storage providers can bid for access to storage deals. We launched this in August, and we are now processing anywhere from 5 to 6 terabytes a day. This gets a lot easier when we have the FVM, and we can actually decentralize some of the pieces that we've just stood up to experiment with. But for this is really exciting. It's moving towards that idea of exchange and movement of data between peers on the network. And we're trying to tune this for DAOs and communities. So one of the projects that we're working with and we're really excited to collaborate with is called Absentia. And so you should definitely check out their work to try to mobilize data from the scientific community into these decentralized networks in a way that nobody can ever censor it, remove it, block it, and it really becomes a collaborative asset in the scientific community, a new form of data silo, a data silo that is open, all of the community can access, and potentially it's forkable. So we can imagine multiple lives for that data asset going forward. That's so exciting to me. We've also built a bridge to this network. So permissionless, fast, and interoperable bridge called ETH.storage. So if you go to ETH.storage, you can take a look at this. And this is meant to bring storage to some of the biggest Web3 communities that are out there. So developers on Ethereum, developers on Polygon, developers on Near, et cetera. And they're able to leverage storage on Filecoin, plus the interoperability of IPFS directly from their native chains. And I want to give a shout out to the miners that are working with us. So if you are one of the miners that's already working with us, you've been awesome. You're helping us build this tap into this network of decentralized storage providers on Filecoin. But so we built a tool so that miners can actually help us move data across the network faster. So they run a simple node next to the Filecoin mining operation called BidBot. If you are a miner and you're watching this, or a Filecoin storage provider and you're watching this, definitely check out that repo. It's super easy to set up. Yeah, you set it up and it gives you access to this auction stream, and you immediately start storing data from the feed. And this actually will help us grow throughput, and it helps us ensure that our users have this globally distributed, ever-growing hard drive. And that's backed by Filecoin's cryptographic storage proofs. Another really interesting thing that we'll be doing here, if you're a storage provider watching, is we're going to have a competition next month to see who can offer some of the best services for storage on the Filecoin network. And so we'll have more details about that the coming week. all of this leads to an idea of a layer 2 for Filecoin, a layer 2 that really tailors storage for communities and focuses on this high throughput data storage, access, sharing, and forking, curation on top of Filecoin. And there's a lot of work that we've been doing to experiment with what this could look like, what are the pieces necessary, and what are the specific features that communities need to store and preserve their data to really encourage this exchange of information. So where is this going? Like I already said, community-owned, decentralized, forkable data silos for humanity. Silos are a key insight, I think, here, because the ability for community to run these silos will be directly tied to their value to capture, or their ability to capture value from them. Recall, data has gravity. So if we just imagine a future where we break up data, so all of us as individuals own it and move it around, we actually lack the total value that we can create as a society by putting that information together. And if we put this information together in a way that the community owns and is forkable, that can also build gravity. So data itself will encourage the growth of more data, of more information, of more sharing. Data network effects for communities, not closed by an organization. And so we're really excited about this vision, and we'll be pushing it hard on Filecoin. And we're excited to take Carl's vision for where humanity goes all the way to the next letter and beyond. So that's what I have to share about bridges today. But thanks, a high throughput storage protocol for communities is in the works. If you want to join us, check out our Discord or shoot me an email. And thanks very much to Filecoin for putting this on.
Awesome. Thank you so much, Andrew. That was one of the best presentations that I've heard this whole time, not to pick favorites, but I also like your PowerPoint skills, so I'm going to have to take some notes from you. Thanks so much, Andrew. All right. And up next, this is the exit velocity track. This is for the protocol innovations and upgrades that are happening on Filecoin. And up next, we've got Charles Cow talking about PhilSwan, which is building a fog computing system on top of Filecoin. So let's go ahead and roll this.
Hi, everyone. I'm excited today to have the opportunity to introduce how PhilSwan is building the metaverse large fog computing networks. Yeah, so first of all, since early this year, everybody is talking about metaverse. So what is metaverse? Different people have a different definition. Some people see that it's an NFT. Some people see that it is some gaming characters, then some people seeing that it's a film. But from my perspective, all of them are correct. So those are the images we already have in the different scenarios. The Atali, the Battle Angel, the VR game, famous VR game, and also another gamer. So everything you can see that they are building on top of the existing technology, but it's something like it's going to happen, but not happen yet. People is so exciting about everything, but we still have lots of steps moving to it. When you, as a nature person, and you want to go to the next stage of the gaming, what do you need? That is lots of technology happens behind it. Imagine that today you take a hit shot and now you hit set and you want to enjoy a different life. But now we already have more science with your phone. We already have lots of some kind of life was predefined by our environment. For example, the nationality, your parents, your home, you're born in a rich family, or you are just in a normal family. You have lots of things that cannot be controlled. But in metaverse, when you start from everything, lots of people can just start from scratch. You create your characters, you log in, and you start enjoy your life. You can get powerful weapons. You can get different digital assets. You can build in your own, even your own kingdom in a virtual world. But it's still virtual, but it's not virtual as well, because something is really real there. It's a connection. In order to build in this metaverse, we need lots of power, which is we need the technology behind it. We need lots of people to connect with from different devices. You maybe from your cell phone, you maybe wear some sensors, you maybe need some headset to connect to those computing resources. However, the current gaming about cloud gaming is you directly connect with something like a stream platform or Google's Stadium platform. It's a remote gaming experience. But some of them, you need to download large data sets. You download large of resource and rendering on local computer. After that, you just upload your data set to the data center on different company owned. But it has one problem. How about this gaming company or those assets company? They change my asset. You can easily convert me back from a wealth people in the metaverse to a poor guy again, just deleted my role because he doesn't like me. Can also doing something like you're in a region, you want to connect to the server like the Diablo 2 recent online, you're always on the queue where other people is happy playing the game. What happens to you? You really need lots of different places to access instead just rely on central server data centers like Amazon, 20 data centers in the world. You need more than that. Another critical thing is identity. In metaverse, we don't really want the current world, which is that some company, you sign up with your account, your registration, and you get an email validation. And as soon as the game controller don't like you, your manager don't like you, you get to delete your role as a penalty. Something happens in Blizzard, in Ubisoft, lots of companies have done it. But why? Why should we have that? The user wallet should be the entry point to the metaverse. Anybody can create a wallet, and this stands for me. My identity is just a piece of characters. What it really represents me is the connections. It's not some ID by government. It's not some ID by central database. It is something validated by the blockchain consensus. As soon as I have the ID online, I have different transactions, connections with people, you can define me in the network. For example, I have a payment, use Ethereum, Filecoin to somebody to buy the asset. Then the asset is online, my equipment is online. It's stored permanently on Filecoin storage. Now it permanently belongs to me and nobody can delete it. And it's bonding with my identity, the wallet. So it belongs to me. I don't need a bank to authorize me to using my digital assets. I don't need a government to tell me that you're good or not. This is something I think in the future metaverse we should have. In Filecoin, recently we already see that in the community there is a GitHub repo talk about the interoperable ID standard. We can take a look. It's really interesting for the future. They can also integrate with other protocols like the loot. You can create the attributes for yourself and build your characters from scratch. Then for the assets is important because that's all you have been working for and what you have. Like you can have a car, you can have some nice skin, you can have unique weapons. All those things will be saved as NFTs. It's for you, it's unique. Even my daughter, she knows that when she has a cute cat, she doesn't want his friend has the same one, right? It should be unique. It belongs to her. So with a blockchain, we can do this. We have the NFT storage recently online with Filecoin. Filecoin company organization has this great community project to allow people upload their NFT asset to the Filecoin network. The Chainlink recently working with Filecoin, so you can have your storage proof online to show that, yes, this is the assets have been stored and it's confirmed. You can make a payment for that. We also have lots of data set from Slingshot, which has over 30 petabytes, which enable people to download that has a different source like scientific data and like the gaming data, some medical data for different purpose. Those data sets are the essential part of the metaverse. Without data, you cannot build a real universe. Also, we need a decentralized computing power. Imagine like the scenario we just talked about in the beginning. If you only have limited loads, like what we have seen now in the lots of computer companies, they only see that we only allow the users from North America goes to this region. We only allow the user from Europe to enter this game. The reason is simple. They don't have so many data centers, so they can only support some region, or because of regulations, limitations, they cannot open it. How about a decentralized world? The decentralized should be free, that anybody can traveling or cross without a boundary. Then you really need the computing resource to distribute it across the world. So not like that nowadays, if you're using Amazon services, which means that you are agree with the Amazon user agreement, then if you have some service, Amazon decided not to provide in the region, the entire region is down. You cannot let the people to continue the work in this region. So edge computing is very essential for the metaverse. We need to let anybody to access the resource from any place, anywhere. The artificial intelligence and the 3D rendering technology requires lots of computing data. It's not just some database or some data center that can solve problem. We have millions of computing resource can be used, especially for Filecoin. On the Filecoin network, currently we have over 700 storage nodes can be reached. And then we have more than 3,000 nodes, close to 4,000 nodes available globally. All those nodes have strong computing power. So what we are doing here, we are trying to bring the data and the computing power together to move the processing and analyze as close as possible on Web3. We already stored over 300,000 DLs on the Filecoin network, which over 400 terabyte storage data available. With over 1 year effort since the launch of the mainnet, we started contact with different storage providers and ourselves is one of them as well. We're also building a community members, over 100 developers currently actively working on building the new metaverse. On the technology point, we have lots of payment. We have lots of components used to support the entire infrastructure of the metaverse. We have a strong cache layer of IPLD, also provide a S3 compatible SDK to bring the existing industry into Filecoin network. For example, the gaming company, the AI company, and some 3D image company that really like building existing infrastructure on S3 or good storage to provide them an easy way to access to the Filecoin network. On the other hand, we're building a ledger services. The ledger services is used for different DAO system, either for payment or storage online proof or for some contracts. Different organizations, different teams, they maybe need a contract to support their team, support their organization in the new metaverse. We also have a unified payment system to support Filecoin payment, also support other blockchain payment as well. For example, the Polygon payment. The reason is simple. In the metaverse, there will be lots of blockchains to go across our universe. They have a different kind of currencies, they have a different coin, different tokens. They want exchanges, they want a decentralized way, a decentralized bank in the new metaverse. So it's very important to have payment way. So we have a strong smart contract team currently building different payment solutions for them. Then the most critical part is the edge computing. We're running the different container as a service to run in a 3D asset and lots of computing neighboring network. The reason is simple. When you log into a new thing, when you have two people joining the battle or two people sitting in the cafeteria, you need to change the light, change the weather, climate, everything accordingly. Those all need a strong computing resource. And you also sometimes want your conversation to be encrypted, to be privacy protection, instead open to everybody. So you need this kind of computing. But you also want your data set with the computing close enough. So we are working with the Meta team to building the citizen access to all these different resources. So when you have traveling from one metaverse, one continent to another continent, you maybe want to cache in your storage, cache in your asset, transfer to another continent. This is the FS3 component. It enables people to just doing the migration data from one place, from existing infrastructure with one click. We can archive your storage by monthly, by daily, and you can retrieve it and rebuild the storage as if you have a disaster happens with your local storage. And then we also have the Raptor to help you to convert in the S3, Google Drive, Azure support to make sure that everything can be unified and stored on Filecoin network. Where we're building a global storage and computing discovery network. We have building the dashboard to continuously connect with our storage providers. This is a screenshot taken by today. You can see that we have detected there are 330 storage provider, and the one we can have connections is 360. We also have some very active working with us, provide their heartbeat. We know they are alive, they are online, they are active, respond to our request. And this is one storage provider who have a profile and tell what he can provide beyond just storage. It has good bandwidth, and we also have a reputation system for them. So we know that who is performed well in the past and who is not performed well. So the reputation will be your new ID in the metaverse. This is the auction market we have. We have three types of different bids for people to access. We have a public bid. If you have some data, want some people to serve it for you, you can open public bid. Or you already know some people has been deal with you and you are really satisfied with their service. They don't need to go through a normal process. You can have a direct bid, which allows you to direct send the storage to his node. We also have auto bid. If you're a newcomer, you don't really want to spend much time to understand system. So it's just supposed to be there. And the reputation system will automatically provide the recommended high score storage provider for you. And you also have a different option to set up the price range, the serving directions, and we are doing the marketing matching job for you. And we also help you to management your process ongoing. Well, this is an interesting feature we have launched last month. And this is the most important part, the computing as a services. The computing service will be ready early next year. Then you'll be able to archive to get your archive data to the IPFS node. Then you can download the data set, start training. With this demo examples, you give people a direct feeling about how can they get a set of different monkeys and recognize who are they from which species. So in Metaverse, you don't really need to remember so much thing, so much knowledge, because as soon as you enter it, it will automatically labeling different articles, different objects for you, even though it's something you never know, they don't need to worry about that. And it's not in data saved in some database. It can be real-time recognition for you, which is really amazing. We're also working with lots of different projects, and we also get the support from Canadian government, from NVIDIA, and also Filecoin Plus, different organizations. It's a really interesting work. And yeah, for people who is interested to working with us, you can go to our website, you can join our Slack, and you can also check our GitHub repo. We have everything there, and we are really working for you. Thanks, everyone.
All right, cool. Thank you so much, Charles. Also had some great slides. Anytime Gerard Butler is in my view, I am happy. So real competition today on the presentation front. This is day 2 of Filecoin Orbit. And now we've got a small break in the programming here. So take some time, refill your coffee, absorb all this cool stuff that's been announced today, and then we'll be right back. And we're back on the exit velocity track. Up next, we're bringing up Kuba, who's going to talk about snap deals, a new extension that's unlocking that 12 exabytes of data storage that Filecoin is currently handling. I don't really know how to comprehend what 12 exabytes is, but I know that it's a lot of data. So Kuba, over to you.
Hello, my name is Kuba Schneider, and I will be talking about snap deals. Snap deals are lightweight sector updates. So let's start. Why are we even introducing this thing? Committed capacity sectors currently represent 99% of Filecoin's 12 exabytes of storage. Committed capacity sectors are not storing any data. They are just miners signaling that they are committing to storing some data in the future. Currently, the available pathway of updating committed capacity sectors to sectors storing data is equivalent to sealing new sectors. So many miners choose to instead seal a new sector. This is the primary drawback of the current update system, and we are trying to improve it. Also, sealing a sector is a very high latency process. We can reduce the latency in the system by using an existing replica, existing sealed sector, instead of sealing a new one. So what are snap deals? Snap deals are a lightweight way of updating a committed capacity sector with cleansed data. We leverage existing properties of committed capacity sector and use it to create a sector with client's data. Storage providers can use an existing sector instead of sealing a new replica, which is a property that we were looking for since we launched Filecoin a year ago. The plan of release for this feature is Q1 22, and let's jump how it works, and then we'll look into what it provides in general. If you have any questions, please leave them in the QA section of the Orbit event. I will look at them at the end. So how do snap deals work? In essence, we encode client's data into committed capacity sector with modular multiplication and addition. It's not a easy to comprehend step, but in essence, it works like storing data into the sector. We don't store the pure data into the sector. We randomize it first to preserve some properties of sealed sectors. You can read more about it in FIP 19. So we perform the encoding process, and then we prove the correct execution of the encoding on chain. So the primary way why the sealing process even exists, what the POREP exists, is we want to create a replica that's incompressible. That's what brings Filecoin its security, and the update process has to preserve that property. So the essential part is the raw algorithm here. You can see it here. So raw is the randomness that mixes the data and doesn't allow it to reduce the randomness and incompressibility of the sealed sector. The ideal algorithm for raw would be pure randomness, but we cannot use it due to constraints around decoding the data later when client want to retrieve it. We settled on bucketed randomness. So instead of having as many randomness values as there are nodes in a sector, we limit the number of possible randomness values. We knew about the possibility of updating committed capacity sectors for a while now, but we haven't pursued that. We pursued that opportunity, but we haven't released anything since till now, because we stumbled upon a major blocker, which was the randomness requirements of this process. As we talked, as I just talked in the previous slide, the randomness for the encoding process is very important because it preserves the security of the system and of updating the sectors and Filecoin as a whole. So we are looking at two different. We have two needs for randomness. One is for encoding, the raw as I showed you previously, and the other is challenge generation, which is used for generating challenges when miner wants to prove an update. The interactive random, normally we would use interactive randomness. We do it for example, POREP. During POREP process, we use interactive randomness, and this allows us smaller proof, but increases the delay. We need to wait for chain to be for sure settled until we use that randomness value. The interactive randomness in this case required 2 stages of interactive randomness, so it was introduced in 3 hours of delay. And this was decided as a major blocker for this protocol because it wasn't as good as it could have been. We were able to reduce that, remove that requirement of interactive randomness by creating one grinding resistant encoding function, which I showed you previously, and 2, grinding resistant randomness by using grinding resistant encoding function, which allowed us to remove the interactive randomness from the first stage of encoding, and Fiat-Shanmir transform for the challenge generation instead of using interactive randomness for challenges. In essence, Snapdeals now is non-interactive one-message protocol, which reduces the time it takes to execute on chain, and also increases its resilience to disturbances and errors implementation on storage provider sides and so on. What does this give us? We get a possibility of onboarding users' data into a sector and proving it on chain in 1 hour. This is major improvement from previously 5 to 6 hours it takes to seal a new sector. And this 1 hour is not hard limit, whenever we improve our proving performance, this time frame reduces. We skip the computational overhead of sealing. So if you have committed capacity sectors, you can include the client's data without resealing sectors. And also we gain a simple one message update protocol, which was a win in its own itself because implementation is way simpler and the integration on storage provider side is also way easier. The quicker onboarding of clients' data unlocks for new use cases, which were previously impossible due to the timeframes. So 5-6 hours is, for some clients, is unacceptable, but now we'll have a protocol that allows us to onboard this data in an hour or less. And also storage providers can upgrade their existing sectors with fill plus deals without resealing to increase their quality adjusted power by the factor of 10, which will be an amazing opportunity for many smaller and medium-sized miners who focus on the client side of things. Storage providers also gain the ability to reuse sector pledge collateral without resealing. So the current update pathway was used by some storage providers because exactly this property, and in this case, it expands it and allows you to do it without resealing. Many smaller miners struggle with collateral payment, collateral requirements, and I can tell you we are looking into storage provider lending programs and storage provider insurances such that lending programs can become cheaper. Another thing is storage providers can onboard clients' data with higher throughput, which is a win both for storage providers and the clients. Some very big clients have a lot of data to onboard, and the onboarding throughput is the major blocker for them. As we are it will be no longer required to compute the complete replica and seal complete replica to onboard clients' data onto the network. These resources can instead be used to update existing committed capacity sectors. So in essence, committed capacity sector become a buffer for clients' data, for future clients' data. So you can imagine storage providers building up the buffer and then using it to onboard client storage. Oh, and finally, most importantly of all, we unlock the 12 exabyte of latent storage on Filecoin network. For reference, 12 exabyte is enough, more than enough to store Internet Archive 100 times over. And it's just unimaginable amount of data, and this will unlock this potential. Talking about the future, it's very much possible that FIP19 will ship with repeated sector updates. So you will be able to, storage providers will be able to update, insert data, deal data into a sector. And if that deal expires or there's some still space in the sector, they can do that process again to insert more data into that sector. Or if the data expires, then can redo the update with new data or even the same data. We are looking into next generation of proof of replication, which would allow this protocol to be even more lightweight and cheaper for storage providers and the clients, because clients at the end of the day are paying for storing that data. We are working on reducing proving overhead, as you probably heard, and I think there was talk about it, or there will be. There was recently a CUDA prover introduced, which reduced the time to the computation of proofs was reduced by about 40%, which is amazing. And we get even faster, if we do these steps, we get even faster onboarding of users' data, because the primary time spent to onboard data with snap deals is just getting a proof done. Yeah. Thank you very much. If there are any questions, I will take them here, but I don't see any. So
let's see. Let me just jump into Hopin real quick. I do not see any, but Vector1 says this chart he can understand. So that's great. You made an understandable chart.
Awesome.
Great. Thank you so much, Kuba.
Thank you so much. I would also like to thank the whole team who worked on Snapdeals, because it wasn't only me. There were a lot of people working on them, and we hope to bring them to you, to clients and storage providers as soon as possible.
Awesome.
Thank you.
Thanks so much, Kuba. We will go ahead and move right along. Up next, we have a pre-recorded session. Will Scott, a software engineer at Protocol Labs, is going to be talking about indexing and interoperability on Filecoin and IPFS. So we will go ahead and hit play.
Hi, my name is Will Scott, and I'm a member of the data systems team at Protocol Labs. We work on the data layer of a bunch of the data transfer protocols and stacks in the interplanetary stack that Protocol Labs helps maintain. And so this talk is looking at content routing and how we find content in both Filecoin and in IPFS, and more broadly, what that part of the system looks like today, and some of the work that we're doing to try and help scale that going forward. And so this talk is looking at content routing and how we find content in both Filecoin and in IPFS, and more broadly, what that part of the system looks like today, and some of the work that we're doing to try and help scale that going forward. So I'm going to start by talking about where content routing is today, and then I'll move sort of up the stack through this talk, so that by the end I'm talking more about how the providers who have content are providing that content out to the network and those protocols. So today, from something like IPFS, content routing happens through a DHT. And what that means is each piece of content, which is identified by a CID, a content ID, which is the hash of that content, is the item that is both being requested and being published. So people who have data that they want to make available to other IPFS users will publish that data into the DHT by finding the around 20 appropriate nodes that make up the mesh and putting a record into them, indicating that they have this content. And so it is a abstraction that looks a lot like a key value store, where the key is this CID, the hash, and the value is that publisher, that location. Part of the way that the DHT works is that in order to prevent stale records, so some publisher saying that they have something and then going away, but you still getting that answer a long time later and not actually being able to connect to them, is that records that get put into the DHT expire after a day. And so publishers who want to keep content available in the current IPFS world republish every day to sort of indicate they're still alive and still providing that content. This has a couple scalability limitations, right? The DHT setup grows very well if the amount of content grows with the number of participants, right? So if you have something that looks like a blog, or everyone bringing their own library of data, and so as more users join and the DHT grows larger, the data can also increase linearly at the same rate. But there's other sorts of quantities of data that are just too big for a DHT in this sort of paradigm, that they'll really overload all of the nodes that are participating in the DHT. So if you imagine wanting to do something like a search index over a lot of data, so think a big library of content, maybe web search archives, other things like that. It just means that there's so many CIDs that each individual participant in the network, unless you also grow the network a huge amount at the same time, will end up having more records than they really can meaningfully supply. And it means that the amount of bandwidth for the publisher who's trying to keep all of that data available gets very large. So we start facing these larger scales of data with Filecoin, and are looking at what is the sort of next iteration of this protocol that we can use to deal with this increased scale. So the focus from my perspective is the thing we want to get right is the protocols, and we'll figure out the ability to iterate the specific mechanism at a different rate if we've got good protocols on the two edges of this. So if we have a good protocol for publishing and a good protocol for requesting and finding data, then we can allow ourselves some additional flexibility and freedom to experiment with different specific implementations of content routing. So what I'm going to talk through next is sort of the thoughts on where we go on those two. So the first is content routing. And so this is a user looking for a specific CID. And we already have an interface in IPFS that is roughly what we might want, which is when IPFS needs to find data, it makes a request that is the content routing interface. And it is, I want to find providers for a CID, and I get back asynchronously, and this is the Golang terminology, a channel that over time gives me the addresses of people who may have that data. And so what we'd like to do is take something that looks a lot like this and expose it over a network interface so that I can have some other external system, either as some other program on the same computer, as a library, or as some remote service, they can serve to implement this interface. And so I think we'll start to see this and some abstraction that looks a lot like this coming to a set of clients that are able to retrieve and provide data from some mesh of IPFS and or Filecoin, and more broadly for content address things. So that's our thought of, what is this simple client side of this interface? Okay, so then what do we do to actually implement that is the next question. And the work that my team is pursuing right now is an indexing solution where we're trying to say, well, okay, can we just make something that happens to know the answer to all of these queries? And this is building on a bunch of great work that's happened over the last couple of years. There was an initial implementation of a storage system that's optimized for these CID hash-based keys called Store the Hash that Volker made, and that has then been ported to Golang, and that we're now using as the basis of a network index system that we're calling Store the Index. So let me give you a brief walk or sense of what that's doing and how that's actually working. So it takes a CID and it uses some bytes of that CID itself, which it believes are generally random, right? Because it's a hash in general. And so what it does is it first uses some bytes of that CID to decide which bucket to look at, right? So it has a bunch of different buckets in memory, and those buckets will point to index files on disk that grow. And so it will use a specific subset of bytes in the CID to determine first a bucket that then points to an index. And then it will use another set of bytes in the CID, again, that it already has, to determine an offset in that index file on disk that the record for that CID should end up in. And so then it'll make a read of that index file at that offset. So this is the first read on disk, and that'll give it a record that has a relatively small, comparatively, number of CIDs that match both that bucket and that index offset. And what it will get in that record that it reads from disk is a pointer that hopefully includes that CID if it knows about it, and the relevant metadata entries for that CID. And so then it will do reads to get those specific metadata entries. And the metadata that we're imagining ends up being stored for a CID is the provider who has it, where they are, the multi-address. So this is this full address info that we've talked about. Basically, it's how to find them. And then also, what protocol they're talking about, and relevant metadata that's protocol specific. So how you actually go about retrieving the data from that provider. And this gets, this is one additional level of complexity than what we have had previously, because now we're having multiple data transfer protocols, both Bitswap and GraphSync, as potential data transfer options. And we expect that there may end up being additional ones. And that's part of the extensibility and flexibility here. The nice thing about this setup is that there's a fixed number of reads from disk that happen, regardless of how many CIDs end up in the database. You do one read in the index to get a record chunk, and then you do a read to get the specific metadata entries that you want. The reason we do the extra lookup on metadata is because we expect that there is sort of, for a given provider, there's many CIDs, right? So if you think about a Filecoin deal, that's 32 gigs typically of data, which has many CIDs within it. And all of those, the process that you should then use to retrieve is the same. And so we can deduplicate and spend a lot less disk resources if we do that deduplication. But it means that there's only 2 to 3 reads from disk for a given CID, regardless of how many CIDs are in the index. And so that means the only thing that we're really having to scale is disk usage. But we end up retaining a relatively low latency. We're optimistic this ends up being, order of 5 or 10 milliseconds to answer a query. Microseconds. Random access disk seeks, even as the database of indexing gets very, very long. Okay, so you've got this abstraction of this library that's able to do, individual indexing requests. It can answer for a CID who has it relatively quickly, and it should be able to scale. But that's part of the story, right? We've still got to answer, how does this indexing component actually learn about all of these CIDs? And then I want to talk a little bit about how we see this sort of evolving in the future. Now that we've got interfaces right, this is one solution, but it's certainly not the be-all end-all. I'm sure that there's already a lot of questions in your head about, okay, so if there's this centralized thing, well, aren't we building a decentralized web? And yes, of course we are. Okay. So the other interface, and this is, I think, right now, the focus on the thing that we want to get right and the protocol we want to get right, is ingestion, which is how do we learn what data various storage providers, be they Filecoin or large IPFS nodes, have, and get that reflected in the network index. So the current thought is that what we're expecting from storage providers is that they will have a hash chain of basically advertisements of what content they have. And they'll expose this list of advertisements and the CIDs in those advertisements as a thing that network indexers can get from them. The reason that we're having this as a sort of hash chain of advertisements that are signed by the storage provider is this is part of that extensibility, which is it's not that the storage providers are pushing or just sort of saying, I've got this data, which would not be, immutable, would allow them to provide potentially different views of their data to different indexers. We want to make sure that the sort of expectation on storage providers is they have one view of what data they have, and that is global, so that as other network indexing solutions come in, they can also use this protocol to get the same view into what content is available in the network. Okay, so what does it look like as either a new Filecoin deal happens for a provider, or they through some other means get an additional set of CIDs? Well, the first thing that they'll do is they'll take those CIDs, they'll make the list of them, and then they'll make an advertisement that points to both that list of CIDs and the previous advertisement. And that'll be their new sort of head of what content is available for this provider. The provider then advertises this, and it's a best effort gossip sub, basically advertisement of I have new data available. And this is on a topic that network indexers can listen to so that they can get notifications for lower latency polls from storage providers who have new data. In addition, we expect that the network indexers will sort of keep track of known storage providers and will pull them on some regular basis to see if they have new content. So the gossip sub is a way to lower that latency in most cases, but there's a sort of a fallback to make sure you are keeping everything in sync. Once a networker indexer sort of learns about this and adds it to its queue of providers that it needs to get updates from, it will use GraphSync to pull first that advertisement and then the list of CIDs that it does not yet have. And there's a couple of reasons for doing it this way. The GraphSync means we only get the portion of the DAG that we do not already have. So it gives us this partial resumption of, oh, I already have older advertisements, I'm not going to re-get them. We also expect that there's a bunch of deduplication in the SIDs, which is a deal that is made to Filecoin is likely made to multiple providers. And so by having this sort of structured through this IPLD setup, the indexer will only have to fetch that from one provider, not from all of them, and not duplicate that work because it knows, oh, this is the same list of CIDs that I've seen in other places. So the indexer pulls that and then adds to its index that these CIDs are now provided by this provider. Okay, so the advertisements either introduce a new set of CIDs or retract and say I am no longer providing some previous set of CIDs. Those are sort of the two basic deltas. And then in that advertisement layer, it says what metadata and protocol should be used to retrieve them, right? Because we expect that for some large set of CIDs, you've got one sort of mechanism. So if you end up as a storage provider having different protocols or whatever, you would do that through multiple advertisements, each with the smaller set of appropriate CIDs that match that metadata. Other metadata that you might imagine is things like, is this available for free retrieval, or is it going to cost Filecoin to do the retrieval? Okay, so an indexer has the SID, maintains it, but let's talk now about sort of what that expectation of the growth and sort of evolution of the index is. So we're doing one index, right? There's one thing which is like, okay, as this scales, what's the plan? And there's two ways that it can scale. You can either scale in terms of having a lot more queries, or you can scale in terms of having a lot more data. And hopefully we scale in both. As we get more queries, likely what you want to do is have caches of recently queried CIDs that end up closer to clients, right? And that takes load off of the actual primary index because many of there will be a small number of CIDs that are requested many times and many CIDs that are only never requested at all. So you can pull that frequently queried head into a set of caches that are closer to clients. The index itself is then limited primarily by that growth, right? Like as those disks get really big, that gets expensive, or it can't pull from the growing number of storage providers in a reasonable way. And so you can imagine sharding it, where you end up with regional partial indexes. So there's some index that looks at storage providers that are in North America, and a different one that looks at storage providers that are in Europe. And you can probably scale that to another order of magnitude, potentially just by sharding across regions. And then the local caches will send out sort of parallel requests back to these multiple different partial shards maybe potentially preferring the local ones because they want to connect clients with data that is closer to them by default. But if that fails, then they fall back to further away shards, and that way you've got a set of fairly tractable extensions that likely allow you to keep scaling this for a while. Okay, but that's all still within the scope of a single trust administrative region, right? There's some operator that's operating this whole system, and this is why the focus initially is on the protocols of both content retrieval on one side and storage provider ingestion on the other side, which is we don't want to be making the only network index, and we don't want to be running the only network index. So there's a few different sort of thoughts here. One is the expectation is pretty quickly we'll end up with federated replicas where other entities also are running network indexes. And that gives you a couple options. One is that clients can query from multiple providers' indexes and can check them against each other to make sure that no one is lying and that these are all sort of operating in sync and have similar views into providers on the network. The other thing in the provider ingestion interface, right, is that you've got this now attested chain that's not mutable from each provider saying what data they have. And that means you can do a dispute process where if the index responds to a query either saying the provider doesn't have it when the provider does, or vice versa, saying a provider has something that they don't, you've got a process where you can show the attested record from the provider and the response from the network index and say, look, these don't correspond, and you can figure out who is lying or who has provided incorrect data based on the underlying provider records from the provider. And so that means you can now introduce a whole set of incentive games where you make it irrational for a network indexer to not provide the standard view of the network. So that moves us closer towards an untrusted or supporting potentially Byzantine indexers, where the indexer itself can be malicious, can provide incorrect information, because you've got a dispute resolution process for those who have grievances. We're trying not to specify fully a protocol for moving towards untrusted. Either, how would you have sort of hierarchies where people who are offering network resources end up slotted into this? Because that will likely depend and be interrelated with a larger set of incentives that need to happen with retrieval that are still sort of evolving, right? So you could imagine schemes, for instance, where when I do a retrieval, there's some sort of finder's fee where the indexing subsystem or the set of indexers that help me matchmake to a given provider gets a percent or of the retrieval cost, or gets some fee for doing that finding. And maybe there's indexes that are fast but only have some of the content and they charge less of a fee. And then there's other more expensive to run indexes that have all of the data but charge a higher fee. So there's potentially some sort of market here. And before we've fully understood the set of constraints and incentives that are useful in structuring that market, we don't want to sort of over specify it. So we're expecting that evolves, and that the right thing in this iteration to get right is those two interfaces, so that we can then iterate and change what component actually exists as that networking interface without having to keep updating the protocol that either the providers or the clients are speaking. So to finish off, we're working on indexing. You can see the code. The network indexer that stored the index. There's a reference provider at index reference provider. And this work, I'm not doing this work, but the whole data systems team that you see in these pictures below is really the ones to credit for this. So with that, thank you. I'm happy to take questions on Slack or through any of these various protocol labs messaging channels, or you can reach me at Will Scott. Thank you.
All right, that was awesome. It was really nice to hear about how they're making Filecoin faster as well. That's just one of the slight critiques that I've heard from some of my friends in the NFT community about wanting to put NFTs on Filecoin. So awesome to hear what's happening in the community at Filecoin. Up next, we have a panel discussion about negotiating Filecoin deals like a boss, moderated by Patrick Woodhead, a technical program manager at Protocol Labs. So Patrick and the panelists, welcome to the virtual stage.
Hello, my name is Patrick Woodhead, and I'm a technical program manager at Protocol Labs, and we're talking today about Filecoin retrieval market. The agenda is we're going to begin with some motivation, not that we need any motivating for everyone listening in to Filecoin Orbit, because I'm sure everyone is super excited about all the amazing presentations they've seen so far. But we're going to motivate the topic of retrieval markets. We're then going to have an ecosystem spotlight with one of the really exciting teams in our ecosystem for retrieval markets, Mile. And then for the second half, we're going to have a Q&A with Mile and find out what they've been up to and their thoughts on retrieval markets in general. So we begin with the motivation. The internet is like a road network with traffic jams and crowded roads. In a road network, let's take Amazon Books, for example. They have distribution centers all around the world, and so that they can deliver books to people who have ordered them online as quickly as possible. And the same can be said for the internet. And the way that the internet provides files around the world so they can be retrieved very quickly is by something which is called a CDN, a content delivery network. And CDNs have these data servers around the world, which are called points of presence, or POPs. The household names for those in the know in the CDN space is AWS CloudFront, Cloudflare, Akamai, Fastly. And they achieve an average of around 25 milliseconds for retrieval around the globe. We'll see some stats on the next slide. I also want to mention here that Web 2 or traditional cloud providers, they separate file storage pricing from file retrieval pricing. So you pay to store your files in Amazon S3, and then you pay also to retrieve files from Amazon S3. And then you may pay on top of that for the CDN layer. So how do CDNs perform around the world? CDNs globally, on the left-hand side, you can see Azure at the top has an average query speed of 22 milliseconds due to retrieve a file from one of their CDN points of presence. But that's a very, very condensed metric. On the right-hand side, we have performance in Africa, where we can see that the retrieval times for the CDNs is much slower, more than twice as slow for the top provider. And this data is from cdnperf.com. And even here, I think we've condensed the data quite a lot because they're optimized to perform in cities, but in more sparsely populated regions and territories, it can take much, much longer for users to retrieve their data. And here, in fact, we've got a list of countries that don't have a single point of presence for one of these Web 2 CDN providers. And lots of them are small islands, so perhaps it's not particularly necessary. They can fetch their data in a performant time from next door countries. But there are also some pretty big land masses here. We've got, for example, the Democratic Republic of the Congo. We've got Greenland. We've got the Central African Republic, Sudan. These are big land masses without a single CDN POP. And that makes us ask the question, why have they not got one of these CDN points of presence? And it's, I imagine, to do with the business model. It doesn't make sense for these companies to build a data center there, to build a power supply to these countries, and to offer this service when there isn't the appetite. So we've spoken about the geographic issues, I suppose, with Web 2 CDNs. I'm now going to speak a bit about the market, the pricing of retrieving data from, in this case, Amazon S3. And this slide is taken from a blog from Cloudflare called AWS Egregious Egress, which is a great name. And they estimate with their calculations that customers in US, Canada, and Europe who are retrieving files from S3 are paying an 8,000% markup to retrieve their data. So 80 times what it costs Amazon to put on that service of retrieving that file is what you're paying to retrieve. which is a huge markup. So yeah, we've spoken about the geographic issues, some of the pricing issues, and that brings us on to retrieval markets. What is the vision? So the vision for the Filecoin retrieval market is to build the world's best CDN by leveraging Web3 technologies. The first part of this vision is just to build the Web3 CDN. It's a fundamental building block of Web3. And if we can provide this service so that DApp developers can have a CDN in the Web3 stack, and it can be the same sort of retrieval times and price as a Web2 CDN, then that's a huge win. But then can we go one step further? Because actually Web3 properties and constructs may allow us to outperform traditional CDNs in certain ways. For example, the content addressable nature of data on Filecoin means that firstly, these point of presence won't have to worry about kind of deduplication of data. They can just store the file once, not multiple times. And we also don't have to worry about cache invalidation. If data becomes stale, we know because it's been updated and it's a new CID. So we're getting a lot of, by the kind of nature of content addressable data, we're getting a lot of stuff for free, which is actually really useful for a CDN. We also, it's permissionless, so anyone should be able to spin up one of these points of presence in the Web3 CDN. And incentivized by crypto economic mechanisms, they can earn coin, and they may even be able to mine coin as one of these points of presence. And that means that if anyone remembers the Fastly outage back in June of this year, where vast swathes of the internet went offline because of a CDN going down, this won't be a problem anymore because we've got a much more distributed network, a lot of points of presence from whom we can fetch the data. And then also smart redistribution of content. Points of presence, there's a really low barrier to entry to spin up a point of presence. So if there's a market, people can spin one up, they can start serving files, and they can start to understand where data is being requested. And it's much more kind of dynamic than the kind of static, more hub and spoke approach of the Web 2 graph, as you can see in these pictures. So I hope I've set the scene for retrieval markets. It's about this Web3 CDN and how we can incentivize people to become points of presence in the network. And the work we're doing at Protocol Labs on retrieval markets is actually a real ecosystem focused work stream. So we've got so many amazing teams in the ecosystem all contributing, and one of which is Mile. And we have Alex and Thomas from Mile here to speak to us today. So at this point, I'm going to pass it over to them.
Yeah, thank you, Patrick, for that great introduction. And thank you, Filecoin, for having us. So as Patrick mentioned, I'm Alexander Cabuto, co-founder and CEO of Mile. So very succinctly, Mile is a content delivery network that is resilient, scalable, and peer-to-peer to suit the long-term needs of Web3 applications. So as a member of the Filecoin community, why should you care about us? Well, we're building the CDN on Filecoin, and we're bringing in new capabilities to the ecosystem. So a CDN and retrieval market like ours can really accelerate retrieval from storage miners, and by doing so can extend Filecoin's capabilities beyond cold storage to hot storage and caching as well. And secondly, because the requirements for running a retrieval miner are much less than a storage miner, we're also lowering the barrier to entry to become a node on the Filecoin network and to earn fill. But DCDNs like ours have benefits beyond accelerating retrieval from decentralized cold storage. We're really developing interfaces that allow anyone to easily extend our CDN by spinning up a new node in an instant. And what we're aiming for is for this ease of use to create a distributed network of caches with no single point of failure, and where the cost of adding a new node is close to $0. And we're really aiming to bring content as close as possible to end users for maximum performance by way of this network. And at the core of what we're building is the Golang interface of the Mile, what we're calling POP nodes for point of presence. So these are the independent caches that can host and serve content to requesting clients. And this interface is currently pretty simple and allows for 4 operations, which are content dispatching, whereby a node can ask other peers to cache content for it. Content discovery, a node can search for specific content. Content delivery, a node can serve content that they have cached to a requesting content. And payments, whereby a node can pay another node in fill for delivering content. So on their own, these operations are really simple, but you can kind of compose them and coordinate them across the network to create more complex capabilities. But paired with these POP nodes, we've also released an in-browser client, which is just a JavaScript implementation of a POP node, which makes it really easy for Web3 developers to cache and fetch content from our network. And this client has a few really impressive features. The first is that it doesn't rely on centralized gateways to retrieve content. So it enables a pure peer-to-peer connection between a browser and a POP node. And this is kind of a rare feature in the peer-to-peer space. And the second is that we've enabled sponsored crypto payments, whereby an app developer or a company can sponsor and pay for their users' payments when they retrieve content. So we have an early version of this client running up on our website at mile.network. Try it out and reach out if you want to contribute. Thanks so much.
Great. Thank you. Thanks so much for that intro, guys. And yeah, I'd like to begin by just saying it's been a pleasure kind of starting to work together recently, hearing more about what you've been up to at Mile, and seeing the really nice UIs that you've built, firstly for your website and for your products. So it always makes it easy to get into the product when you can look at it and it looks nice in the first place. So yeah. First question I'd like to ask is just kind of speaking generally, we've touched on this a bit already, but why do you think we need a Web3 CDN?
Yeah, I mean, a very fair question. I mean, as you mentioned, decentralized CDNs kind of serve their current purpose really well in the areas that they are. They deliver content in a really reliable fashion. I think some of them serve trillions of requests a day, so nothing really to spit at in terms of performance. But the problems that we foresee are twofold, and you kind of touched on this. The first is that, these CDNs kind of serve the world unevenly, and they haven't really expanded beyond big population centers in, the US, the EU, and Asia, because it really isn't profitable for them to do so. And the second is that because of the management of this infrastructure is super centralized, when it fails very, very visibly, as you mentioned with the Fastly downtime in June. And in our quest to kind of make the web ever more reliable, we should kind of aspire to reduce the risk of these kinds of failure. And it's really our thesis that a decentralized CDN can kind of supplement existing CDNs by providing a dense network of content delivery points that can expand to where existing CDNs can't go. They can do so at a really low cost. And because they don't have a single point of failure, they can provide a more reliable baseline, basically, for content delivery.
Awesome, thanks. Yeah, I love the idea of the kind of zero cost to spin up a POP node, and the idea that it could be on someone's phone or laptop. These are just supercomputers that people are carrying around, so that the network becomes much more dynamic and low barrier to entry. So you've also spoken a bit about this, but would you be able to go into a bit more detail about what Mile are currently focused on? What's interesting you at the moment?
Yeah, for sure. I mean, something that we touched upon towards the end, and I think Thomas can kind of expand on, is that we're really trying to make the developer experience of using the network as easy as possible. And part of that, is enabling browser-based retrievals. So yeah.
Yeah, we've been working on kind of making it easy to run clients in the browser so that it doesn't really disrupt the regular front-end experience on how you would normally build your UI and consumer content. And we've actually had two options available now. One of them is running the client into a service worker. So it's essentially acting as a proxy. So you just make normal HTTP requests as if you were targeting an IPFS gateway, for example. and then the node that's running in a different worker in a different thread, essentially in the background, will kind of intercept those requests and then find the provider and then make those requests immediately. So you actually don't need to hit any gateway or anything like that. Then you're really running a node inside of the browser. And then for those who don't want to add, for example, a service worker, because it still, adds a little bit of, download time on the initial load time, for example, or others who don't want to use this. We're also kind of running those clients inside of Cloudflare workers. So it's kind of an intermediary where it's already running on the edge and can already find very close nodes from there. So it's as if you would request as well normal HTTP requests, but then you just spin up a client node in the browser, on the Cloudflare edge really quickly. So that's also something we're using to make it easier, but still, quite decentralized to query content from our network.
Awesome. Thanks so much. It's nice to go into a few more of the kind of technical details there as well, just to give people a flavor of what this is really about. So I know that you've been traveling the world recently, looking to deploy pop nodes around the place. So my next question is, who wants to use this? Who do you find are your users? Who's interested? What sort of categories of users are you looking at?
Yeah, so at the moment, the people that have expressed the most interest, or I shouldn't say people, I should say organizations, are really, deeply crypto native organizations like DAOs who have, community treasuries in cryptocurrency, and they need to be able to deploy those funds to then, buy out infrastructure, basically, whether it's origin servers or CDNs. And because everything we do is essentially enabled by crypto payments, we're a great fit for those sorts of organizations who want to function autonomously and leverage their treasuries basically to hire out infrastructure. On the decentralized app end, obviously NFTs really content heavy. NFT platforms really content heavy, want to be able to serve content like videos in a timely fashion. Obviously want a decentralized CDN, and they're already using IPFS in the back end. And because we're kind of interoperable with that, we're a natural fit for them. But we're also seeing some interest from, centralized CDNs we know there's some initiatives internally to kind of explore IPFS and other peer-to-peer technologies and as an extension of what they already have.
Yeah, and to add to that as well, I think we've been doing also a lot of research into who is running the points of presence and what the experience should look like, because we're not looking at a different way where people are going to build server farms, and that's in that sense we're really looking at who are users inside of urban environments or, people with regular laptops, what that experience is going to look like for them to run those nodes. Are they going to trust to download some third-party software, see what ends up on the devices? So we're also doing a lot of user research on that front to really understand what it will take to deploy all the POPs at the edge to a very, very large audience.
Awesome, thanks. So next question is, looking forward, what are the biggest question marks around kind of where this is going, the research that's got to be done? What keeps you up at night for how this progresses?
Well, a few things. But as Thomas mentioned, the longer term vision obviously is one where the network and the nodes are as distributed as possible, and you want to bring it as close as possible to end users, because what's really key in content delivery, like physical distance, is actually kind of king in performance in this space. If you get content as close as possible to your end users, so basically all of that to say that building this very distributed network with lots of nodes is going to require fine-tuned and very carefully considered crypto economic incentives to incentivize people to serve content on the network. So making sure that they're getting paid an amount and whereby they would basically contribute excess resources to the network is something that we're actively working on and researching. But we're also looking at leveraging potentially like non-economic incentives. Obviously, this is a bit of a softer topic, but if you're a user who wants to contribute to a decentralized application that you really care about, maybe there's incentives already there for you to contribute your excess storage to cache, some of the web assets for the applications that you already care about. So kind of balancing those two incentives, the softer incentives with the crypto economic ones is something that we're looking into for sure.
And as well, I think we're really looking at how to scale the payment infrastructure, and looking at what it's going to take to get to the highest speed possible and still be able to handle all those micro payments, on the Filecoin blockchain. So that's definitely something we're also researching actively at the moment. But we're confident there are solutions out there. And there's other groups looking, on the actor side to improve the performance and the user experience around payment and state channels on Filecoin. So we're definitely actively testing these and looking at what is needed to get to that.
Awesome. Yeah, I think I know the work you're alluding to, and it's very exciting. Some of these other things happening in the ecosystem. So, final question: what would you recommend to other teams who are looking to get into this retrieval market space? Yeah, we want to build the ecosystem. We want more teams to get interested, to get involved, because there's so many different problems we can solve. So, what would you recommend?
I think everyone should come introduce themselves in the retrieval market channel on the Filecoin Slack first off, and then really kind of look at and obviously start a conversation and look at where the holes are, because there's still some gaps, and I think it's really important to figure out what people are not working on and just kind of fill those gaps so that we don't duplicate the work. And so really communicating on what's interesting, what are your strengths, and figure out, where is your place in the ecosystem. And that's kind of what we've been looking at and collaborating with other teams and figuring out how we can all, leverage each other's building blocks. And then, help each other when you're stuck. That's also pretty useful.
Yeah, for sure. I guess for context, there are other teams working on the retrieval market problem, and we're all kind of tackling different aspects of it. So there's a great community feel. And obviously there's some outstanding problems with all these teams that we can all help direct you to like problems that need solving.
Awesome. Well, thanks so much, guys. It's really exciting, the work that you're doing. I'm really excited to see where it heads. I can also see some people coming up next from the ecosystem to speak. So it's just the ecosystem around retrieval markets is really exciting. If anyone does want to get involved, head to retrieval.market. It's that easy to remember. It's just put it into your URL bar and press enter. And from there, you should be able to find anything you need to get involved. Thanks very much.
Thank you.
All right, great. Thanks so much, guys. I will also put that URL in the chat and open just in case, people can just click from there, make it super easy for them. Also, I wanted to remind everybody that we are using the hashtag FilecoinOrbit. So we'd love to see you all in the audience out there tweeting about the most interesting topics and what your favorite part of the day was. If it's me, that would make me feel so great, but it's probably not. That's fine. Anyway, now we've got two folks from Kin Labs here to talk about building what is basically a search engine for Web3 and specifically for Filecoin data. So I'll bring up Tao Xing and William to tell you all about it.
Hello, everyone. It's our great pleasure to be here to celebrate the Filecoin Orbit event for 1 year anniversary of Filecoin mainnet launch. For past 3 years and for past 1 year, I have spent most of my time on the Filecoin, from from testnet phase 1, phase 2, and Swiss race, and to the Filecoin mainnet launch. It is a really amazing journey for past 3 years. And for past 1 year, I left IPFS Force and set up a new startup of Kin Labs and focus on the next generation cloud for Web3. And for the next generation cloud, there is 3 parts: computation, storage, and CDN. And today we will introduce our working on the CDN and about the control plan of the CDN. And my teammates, William, will give a detailed introduction about indexing the dataverse, deal and the data indexing.
Hello, everyone. This is William from the Kin Labs. So I'm going to talk about indexing the dataverse, so deal and the data indexing from Kin Labs. Okay, so this is the agenda today. I'm going to briefly introduce our Kin Labs. Then we'll move on to time rows, the indexing solution that we are going to index. We will be indexing the dataverse. So there will be a couple of aspects. I'm going to go through all of them shortly. So at last, I'm going to talk about the time rows status, the time rows to date, and the future plan. So this is our team, the Kin Labs team. Kin Labs have rich experience in IPFS and Filecoin ecosystems. As a pioneer of Web3, Kin Labs are leading some key researches and experiments in consolidating and improving the IPFS infrastructures. Now, Kin Labs is closely cooperating with protocol labs in multiple areas, including the research and engineering. Now, we are building the Cloud 2.0 based on IPFS. So based on the content, addressable computation, and storage, we have introduced the ideas of SDN, I'm going to talk about shortly, and the incentive mechanism of blockchain to build the next generation of cloud operating system. So from the chart on the right bottom, so you will see the Kin Labs Cloud OS architecture. And the OS will cover the computing, storage, and CDN. There will be 3 planes. So data plane, control plane, and the incentive plane on the top, which will cover all these 3 areas. Now, let me introduce what time rows. So the time rows is the indexing solution that for the dataverse, it will be integrated with the storage market and the retrieval market. I'm going to go through all these different aspects. Firstly, let me compare the indexing with the marketplace in Web 2.0. So the data value chain of Web 2.0, probably you can say is broken. So in Web 2.0, the data are silos with ad-based revenues. And in Web 3, you can see the chain has been unified in the metaverse based on Filecoin and the IPFS protocol in the following industries or areas: the content curator, search engine, marketplace, and payment or lending. Let's take a look at indexing from Web3 perspective. So in Web 3.0, the indexing is more like a curation service, where in Web 2, the search engine enterprise that make money from advertising. So from the chart below, I'm not going to go through all the big brands, but they are mainly covering the 4 areas or industry businesses. So like the creator and consumer, indexing, marketplace, and the payment or lending. So let's take a look at CDN, which is a very important product in Web 2.0 with the SDN. So what is SDN? SDN is software-defined network. So the history of the internet maps roughly to the evolution of the following aspects in the face of challenges, including the control schemes for managing reachability information and protocol for the distribution of such information, and the algorithmic generation of the optimized paths. So let's view the indexing from the SDN or software-defined network perspective. There are two main features required: discovery and the delivery. For discovery, we at least need search and the information curation. In terms of the delivery, we need the SOA of the delivery. So these are how we view the indexing from the SDN. So on the right-hand side, you can also see the general or the high-level architecture of the network. So from the top-level application to the controller. So let me tell you about the Dataverse and the difference between Dataverse and the data lake service we probably already know in the Web 2.0. In a sense, we are building a wide area network data lake service based on IPFS. So let's take a look at the chart below. So we have a comparison. So in the Web 2.0, we have the big brands that provide the cloud service for structured, semi-structured, or even unstructured data to the top layer, the application layer. So in the Web 3, we believe the data source will be IPFS, Filecoin, and on-chain data, including the Web 2.0 on-premise data sets. On top of this, all these data source we need the indexing layer, which provides the data provider discovery mechanism, the content searching functionality, and the information curation mechanism. We also need a scheduling service and the data analytics feature. On the top, we will build the query API, which will power the application layer. Okay, you can see. So this is how we can see the architecture evolution. So the standalone host or node, the architecture has been transformed into a decentralized organization. So each node of the network contribute to all the features or the interfaces of query, storage, and the integration. They cooperate with each other and build the control plane and serve on top of the data plane. So this is how we envision the architecture of the indexing. So we need at least the data provider abstraction. So where are all these data coming from? We have the marketplace, they contribute CID, and we may have actors. They can be human beings or some even just AI that produce a label, tag, or keyword of any content. They will act also as a data provider. At the same time, surely we have the IPFS data and the Filecoin data. They can be also the two main provider. Don't forget, we also have a huge amount of Web 2.0 data sets that are the on-premise data. We have the solution of IPFS watching that gives the synchronization mechanism to allow the Web 2 data sync to the Web 3 network. So this is also one type of the provider. So in all these data provider, we have the indexing support. So for Filecoin data, we have the DL indexing. From IPFS and the other file content that need to be on the IPFS network, they surely have the CID indexing. Based on all these basic indexing functionality for CID, we can provide the full text indexing, which will eventually allow the end users or any application to consume the full text indexing feature and provide to the end user application or functionality. Allow user to efficiently find content in their most familiar way. Okay, so we are building something. Let me show you how the time rows looks like to date. So this is the rough, a general or high level architecture of the time rows. The data will be coming from IPFS and IPFS crawler. So IPFS will produce the file content metadata and get it ingest to our time rows. At the same time, the IPFS crawler will find content and produce a CID and provider pairs. These data will all be ingested to the time rows and form the CID index. This index will also power the full text indexing. These two main functionality or components will be the base of time rows, which will be the source of the IPFS API, HTTP API. So these API can be used in two main aspects. One is the IPFS itself. It can be a more efficient way to find providers of some CID. At the same time, we're also building the time row search engine, which is a web application. It will utilize the HTTP API to help you find provider of a CID or do the full text in searching. At the top of the chart, you can also see the IPFS watch. This is a solution for the regular file system. So imagine you have a huge amount of data, a data set from your local file system. It can be some enterprise data. You want to get it synchronized to IPFS network. So you don't want to put all of them to the network to duplicate the data. So you can use our IPFS watch solution with a no copy support, which means the content won't be copied to the network. At the same time, all these files will still be indexed to the network. The network users can still find the content and consume. So this is how time rows is designed. This is a simple page, front-end page of the search engine, just like a regular search engine. So you can input some keyword and it will return you a list of files that match that keyword. And when you click the item or the link, it can be redirected to the original file content over the IPFS gateway. Also, if you want, you can also provide the CID. The search engine will return you the provider if it's found. Also, alternatively, if you do want to just search as a keyword, it can also work for you. It will try to find some files that have the CID as a content or part of the file name. Okay, now let me briefly go through the crawler I mentioned just now. We built the IPFS crawler. It will be sniffing on the network and look for the CID and its providers, get all of them indexed. So you can see there are two lines there in the chart, the dashboard. You can see the blue line is growing much faster than the green one. That's because, so the blue one is for the total records or the CID provider pairs indexed. The green one is just for the unique providers, which means in the long run, you can see as we have providers with multiple sets CID, so the green line is growing much slower or even just sits at the bottom of the chart. So if we just view the green line, so the provider, the unique providers, is growing steadily. So it's looking for providers and the CID from the network. All these data can be fed to the full text indexing and the build. the search engine with more and more content. So end user can consume from there. Then let me give you a summary. So for now, the time rows gives the IPFS with a feature of optional file indexing. So user can choose to use indexing option to get their file indexed into time rows. IPFS CID indexing is surely supported by time rows. And the IPFS full-text indexing, as just mentioned. So IPFS process can use the time rows API to find providers which can be more efficient. And our IPFS content crawler will give the metadata aggregation support. The search engine web application gives you the ability to look up CID provider and full-text search. So what's next? We have a future plan, as you can see. We are going to segregate a full-text indexing service. For now, it's embedded and it's a standalone time rows application with all the modules components embedded. We're going to segregate the full-text indexing and make it as a processes can be separately executed and run in the network. We also want to support P2P API in time rows and the Filecoin miners site indexing support. We're also going to build more features with user-friendly in the search engine. And for now, it's a centralized architecture. So in the long run, we hope we can decentralize and provide to the community. At last, it's an incentive mechanism, which is key to the success of the time rows. Without incentivization, so there won't be engagement from the community to run the indexing service or the index node. So the more executed or running in the network, the more indexing data and the better quality indexing can be in the network. So this is our future plan. Okay, so for the better future of the Web3, feel free to reach out if you have any question or query. Thanks.
All right, thank you guys so much for that presentation. And we are going to keep things rolling here on the exit velocity track. Our next discussion is about the use and future directions of SNARK technology for Filecoin. And to present on this topic, we have Anka and Rosario, so I'll hand it over to them now. A few technical difficulties. We will be right back. All right. Sorry about the technical difficulties. It's always going to happen in a virtual show, so no worries. We're getting back into it. Let me welcome Anka to the virtual stage.
Hi, everyone. I'm Anka from CryptoNet Lab. So I'm a research scientist and I'm working on cryptography on SNARKs from Filecoin. So I will talk today about some recent work we did about SNARKs in Filecoin. And later on this presentation, Rosario will take over and talk about future directions in this area. So we all know that in Filecoin we have proof of storage, and the proof in this is done by this powerful tool that I will present today, the SNARKs. So to have a little bit of terminology, the miners, the storage providers in the network, are responsible of onboarding storage capacity, and they do it to earn block rewards. So they have to regularly prove that storage, and we will call them provers, as in the cryptography protocol for proof systems. On the other side, we have the nodes in the network that need to check the validity of such proofs. So to ensure that the data is being stored and maintained and secured as expected. So those are the verifiers. So we need to find a way to prove storage in an efficient way, in a scalable way. And that was done by the help of these cryptographic tools, cryptographic primitives known as ZK SNARKs. And their name comes from succinct non-interactive argument of knowledge, and the ZK in front is from zero knowledge. So what are these proof systems? They are perfectly fitted for a distributed system as Filecoin because they have a very short proof size, so they can fit in blocks in the chain. They are non-interactive, so they don't require any extra communication between the prover and the verifier of such a proof. Just publish the proof and the verifier can come and check it. They are arguments in the cryptographic sense of security, so their soundness holds with respect to malicious provers that are computationally bounded. And they are even more than that. They have this knowledge soundness property, which means that wherever a prover has to show that a statement is valid, it also shows that it knows a witness for the validity of that statement. So it knows all the process for computing something, not only the result. And we can also add an extra property that we like for privacy. So zero knowledge guarantees us that the proof itself doesn't reveal any extra information other than the validity of the statement. So a prover doesn't have to reveal extra sensitive data other than the storage it wants to, the validity of the storage. So in proof of storage, how do we do it? Any storage provider has to divide their storage capacity into this partition of 32 gigabytes that will be later on encoded in a more complicated way. I will not detail this here. And the storage is proven, this valid encoding of available storage is proved with 10 SNARKs, with 10 proofs for each 32 gigabytes. So we have to submit these SNARKs to the chain. And at some point, we will have too many SNARKs, even if they are succinct. They will the current block will be filled up with SNARKs. So we need to find a way to scale well those SNARKs. So it used to be that we have an onboarding limit of 40 petabytes per day of storage because of these SNARKs that were accumulating in the block. The verification of these SNARKs also takes time. So what we do when we have many SNARKs, before finding a solution for scalability, we still had a way to make the verification fast by batching it. So a verifier in the network will take a lot of proofs, a lot of SNARKs, read them, so it will be long, but merge them together in order to verify them all together at a single port. And what we are doing now with SNARKback, we solve the scalability in the sense that instead of the verifier to read all the proofs, the prover itself can just aggregate the proofs together into a more aggregated proof, which we call SNARK back proof, and the verifier will have only to read this small proof. So in brief, we have many SNARKs that don't fit in a block, and instead of putting all of them there, we will just apply SNARK back and aggregate all these SNARK into a much smaller proof, which is logarithmic size in the number of the original initial SNARK proofs. So what are the challenges for constructing such a protocol, the SNARK back? We use some existing work on other type of proofs, like inner pairing product proof, that allow us to commit to a vector of SNARK proofs and show that some inner pairing operation hold between those proofs, which will allow to verify validity of all of the proofs together. So each SNARK, it's made of 3 elements, A, B, and C. So we will commit to all this vector of SNARKs in 3 different commitments, which correspond to those elements. Unfortunately, this tool is very nice and can be used to aggregate SNARKs, but it has a drawback. It had a trusted setup, which in practice needs some very complicated ceremony to generate these public parameters that will later help to construct the protocol and to run the protocol. So that's not something fast and easy to organize. And we already have done it for the original SNARKs, which also have trusted setup. So we already had some trusted setup, and we will think of just reusing that. So our idea was to take the trusted setup from Filecoin and another compatible trusted setup for the same SNARKs from Zcash, and build from them a way to aggregate the SNARKs. So SNARKback reuses those trusted setup, doesn't have to run anything new, and allows to commit to this vector of many SNARK proofs in a compact way, and apply these to previous works, as I said, on inner products, in order to prove that all the SNARKs were valid. So what the verifier does, it just has to read log n commitments that come from these proofs of inner product, and to do a final check that will guarantee altogether that the initial SNARKs were all valid. So we implemented the solutions. We have it in Rust. It's optimized in the Bellman framework. As I said, the public parameters are generated already from existing ceremonies from Filecoin and Zcash, and this is also this combination is also available in a code. And the benchmarks look really nice. So the proof size, compared with the batching, which grows linear in the number of proofs you have to look at as a verifier, is it's really small. It's logarithmic. So more SNARKs we have to aggregate together, better proof size we achieve. Then we have the verification time, which is very nice compared to batching techniques. So we see here that verifying more proofs doesn't grow in efficiency. So we have the aggregation time also. A prover who wants to aggregate many SNARKs, for example, 2 to the 17 proofs, will do it in 2 minutes and will onboard a very small proof on chain. What to do next about this? So we have still room for some optimization, and we are working on either more theoretical version of SNARKback, but also some implementation optimization. Also, we would like to upgrade these techniques to transparent aggregation. What I mean by transparent, there are new SNARKs out there which don't require any trusted setup. So we would like also to have a way to aggregate them without trusted setup or different techniques that don't require this. And we will keep this SNARKback in mind. Each time we will need to use the same kind of aggregation techniques to schemes that are similar to SNARKs, which have this structure pairing-based cryptography inside. So it's time for even more future directions in SNARKs, and I'll leave the stage to Rosario.
Yes. Hi, I'm Rosario Gennaro. I'm also part of CryptoNet Lab. So Anka, can you move to the next slide? Yeah, so let me briefly say what CryptoNet is working on to continue to improve our SNARK offerings on Filecoin. And I'm going to touch on 4 specific topics: better vector commitments, recursion, SNARK VM, and more applications. So can we go to the next slide? Okay, so let's go back to what Anka was talking about, the proof of storage. The way proof of storage works currently is that you have this 32 gigabytes that you can think of it as blocks that they're committed into a much smaller digest. When what we use for this commitment is a classic cryptographic technique called the Merkle tree. And what the SNARK basically proves, remember Anka said that a SNARK proves knowledge. What the SNARK proves is that I know enough blocks in this big digest that you can see in the commitment on chain. So one question that we're working on is, can we find better vector commitments that allow this proof of knowledge to somehow be more efficient? That means a smaller circuit, a smaller proof overhead in terms of how long it would take to produce these proofs and how computation intensive it is to produce these proofs. Next slide, please. Another question is that we would like to be able to reuse this packed proofs that Anka talked about. So one thing that Anka mentioned was that current proofs have this format. There are 3 group elements. In a cryptographic group, there's A, B, and C, and that's a proof. There's 3 elements. And so then we have a vector of these proofs, AI, BI, and CI, and Anka showed you how we can compress them into 3 single commitments to all the proofs. And then we somehow aggregate the proofs and aggregate the way to actually prove that they're valid. The problem is that these commitments A, B, and C to the vectors are now in a different group, G prime, not the original group where the vector came from. And these packed proofs cannot be fed into another packing procedure later on. So once you pack them, it's done. So what we would like to have is a vector commitment that doesn't change from one group to another so that it could be reused. It turns out that in the most general form, this is actually impossible to achieve. So it's not like we're looking to, prove something that cannot be done, but we're trying to maybe find an efficient way to map one group into the other and one commitment into the other. That's okay, you can move ahead. So this is a more general issue, which is, can we break computation into smaller chunks and verify them independently and use the result of verified computations as input for other computations? So can we somehow prove something and use that proof as an input for something else that we want to prove? And there is lots of work in the cryptographic community about this. In particular, there are 2 systems that right now are the state of the art. One is ALO2 from Zcash, and another one is Nova from Microsoft Research. But there's more, and there's a lot of research in this idea of recursion for SNARKs. And we are trying to figure out what is the best way to use recursions in the kind of proofs that happen in this particular proof of space that happens in Filecoin. So next slide. Okay. And all of this is going to eventually come up into a SNARK virtual machine. And what do I mean by that? So what we're trying to, and this is not just Filecoin, the entire community is moving towards this direction, is that we want to remove the SNARK aspect out of the picture. We would like to be able to program code that in any programming languages, particularly like Solidity or JavaScript, smart contracts, that they would immediately compile to a verified computation. So you shouldn't be relying on cryptographic experts to build a SNARK for your computation. There should be a system where you code it and it gets compiled into something that produces a result and a proof of the correctness of that result. And of course, the biggest challenge here is to make it scalable when you have a very large program. So we have sort of, the way we're thinking about this problem, is we have sort of divided into three parts. One is the front end. What kind of language is best suited to be mapped to a VM instruction set that can be then optimized to build circuits that can be used inside of SNARK? And some of you may have seen the LURK Metaproof talk earlier in the Orbit conference, which is something that the Crypto Compute Lab is working actively to build. Then this front end would be fed into what we call a middleware, which is exactly all these techniques to aggregate and recurse on proofs that comes from different subroutines. So if you write code that are subroutine, you would like to verify each subroutine individually and then combine these proofs of correctness into a single proof, similar to what we're doing for SNARK, but now for a general computation. And a big challenge, a big technical challenge comes from memory management. What I mean by memory management, you need to somehow prove that the way you change memory is correct. What you write and what you read from memory is correct. And this can be done also via efficient vector commitments. And then the back end is what is the best cryptographic proof system that is going to fit into all of this. And I think I have one more slide. Just an example of how also we're thinking ahead to other possible applications that we can bring in with SNARKs. One possible thing here, it's a very powerful tool. And let me give you an example of what we would like to build. We would like to build the ability to communicate confidentially through a secure channel through people who know something. So think of, for Filecoin, the ideal applications would be, think of IPFS, and I'm going to announce that I want to talk confidentially to the owner of a particular file. So one way, what you need is what in cryptography called witness encryption or witness key agreement, the way to encrypt messages that can be decrypted using an arbitrary secret, not necessarily a cryptographic key. And what we know is that SNARKs can somehow be used to build something like this, at least in the two-party setting, and we've tried to figure out if that can be extended to a group setting as well. And of course, with the usual issues of scalability and efficiency that come with this kind of problems. So this gives you like a very high-end, views of what the crypto net group is working on. And I'm done.
Awesome. Thank you so much, both of you, for that talk. And we are going to take a very short break. We're almost done with the day, but please stick around. We'll be right back. All right, we are back. I told you, really short break. We have got tech talk after tech talk after tech talk. It is really great. Next up, we have Hannah Howard, an engineer at Protocol Labs. She's going to be talking about graph sync, bit swap, and better data transfer algorithms for Filecoin and IPFS. And I have seen her first slide, and it's really amazing. So, Hannah, welcome to the stage.
Hey, hi everyone. I am so excited to chat with you today about our evolving data transfer protocols in Filecoin and IPFS, and how we're going to make the distributed web more reliable, accessible, and interoperable. So my name's Hannah. I am a programmer with the Web3 data systems team at Protocol Labs. I've been working on IPFS and Filecoin for about 3 years, and honestly, in my entire career, I have never worked on more fascinating technological problems than I do now. And I hope by the end of this talk, you are as interested by them as I am. Also, Bailey, if you like the first slide, there is a lot more David Bowie coming because my Filecoin orbit theme fell to earth and it's full of space oddities. So let's go ahead and get started. I want to start with a very simple question. Do you trust the data that you download on the web? When you enter a value in your web browser, how do you know the content that you were looking for is actually what you got? And the surprising answer is you don't really know. In the traditional web, if the website uses SSL, you have some guarantee that you're downloading from the right site, but you still don't know if you're downloading the right data because you don't know if that site's been hacked. Plus, SSL is like pretty cumbersome to set up and maintain for people who are running websites. And while there are, in fact, ways to check your data, they're so cumbersome that only the most technical people use them. So it's somewhat surprising that the whole web works at all. But in the distributed web, we want to do better, right? And that's what I think is one of the most core innovations of IPFS and Filecoin. We've developed data formats and addressing schemes that provide much better guarantees about the data you download. Trusting data is no longer about who you get it from, but rather whether it matches a cryptographic contract that's built into the address that you use to find it. Put simply, you cannot download something you did not ask for. So let's talk briefly about our data formats and what they enable us to do. The first thing I want to talk about is a content identifier, or CID. It is a way to identify content that is cryptographically secure. Inside of a content identifier is a cryptographic hash of the types of the block of bytes that you're going to download. And a CID also contains information about how data was encoded to help us interpret those bytes at a higher level. As a quick aside, CID is sometimes pronounced just SID, and I'm going to try not to do that. That's sort of an internal shorthand we do. But if I do, just that's what I mean. But I'm going to try to say CID. So most blocks of bytes on our network decode into a structured data format called IPLD, or interplanetary linked data. This means that you can take the bytes you get for a block and decode them into something much more meaningful. And the data model of IPLD is similar to JSON in that it has basic data types like strings and numbers and collections like lists and maps. However, IPLD also supports embedding content identifiers into that structured data, and that allows us to break up large data sets over lots and lots of blocks. In the sort of contrived example you see on the screen, we have a list, and it has two maps inside of it, and the first number is a CID, and in the first map there's a CID that links to an image, I'm calling this cheese image, and then there's a string value, and then in the second map you've got there's a number value, and the second map has a CID that links to further data, as well as a string value with the name of the fruit in this case. The linking in IPLD is in a lot of ways very similar to HTML. It is almost a hypertext format, but it's structured data that a computer can understand. And the links are CIDs that will guarantee we get the right data. So fun fact, almost all data that is stored in Filecoin is encoded in IPLD. When you make deals in Filecoin, you probably make them for files or directories, but all of those are encoded to IPLD formats before they get transferred. And that produces some unique advantages that we're going to see in just a moment. Large data, so that's our format. And then large data sets in IPLD can get spread out over multiple blocks, where each block is identified by its own CID, and embedded into the IPLD data for that block are links to other blocks, all going back to an individual root block. We call this a Merkle DAG. The awesome thing about this is while the root CID is just a hash of the initial blocks in the first root block, you can use it to incrementally verify the entire graph. Once you find and verify the first block, you can go, you have CIDs for the next blocks, and you can go find them and verify them until you can keep going until you know the whole graph is cryptographically the data you wanted. And we've even written a query language for IPLD called selectors. And selectors allow you to describe partial traversals of IPLD data sets. So if you encode, for example, a large data directory tree in IPLD, we have a way to describe a path from the root to that whole subdirectory deeply nested that can be cryptographically verified. There's a lot of benefits that emerge from these core data formats. Using CIDs means you never get the data. You never get data you didn't ask for. We've talked about that already. And since you can verify data, you can verify the integrity of data, it doesn't matter where you get it from because you know it's the right data. IPLD formats allow us to break up large structured data sets into incrementally verifiable chunks. And that means we can get data faster, but we can ask lots of people for smaller parts of the whole. And plus we never need to, if we have a single chunk that appears twice in a graph, we only need to send it once. Finally, we are starting to see the building blocks here for trustless payments for data. If I can verify data incrementally, I can break large transfers into much smaller transactions, minimizing risk on both sides for a paid transfer. So let's talk about the technologies we built for moving all this data around. One of my favorite parts about working on IPFS and Filecoin is that you almost get to start over and work on and try to write the core protocols that power the web and do it better. It's like programming in the 90s and you're trying to figure out how to implement HTTP or early file sharing protocols like Napster, but do it better. So the first distributed protocol we implemented for IPFS was BitSwap. And BitSwap is a block exchange protocol. It doesn't actually understand anything about IPLD. What you can do is you can ask for a CID and get a block from a peer and get a block back. It's kind of like BitTorrent in that sense. You ask peers for individual parts of a larger data set and then assemble them yourself. The IPLD knowledge here lives entirely outside of BitSwap. Usually it's on the client who's requesting data. This has some really great advantages, and that's why BitSwap remains the core transfer protocol in IPFS today. There's some great things about working at the block level only. First, since you're only asking for one block at once, it's really obvious how to break up requests among many peers. You just ask different peers for different blocks. And since you're breaking up requests, it's easy to make them in parallel. And plus, because the person who's sending data in response to a request is only sending block data, they're only sending bytes, they don't have to understand the format that those bytes are encoded in. They don't need to know anything about IPLD. Plus, BitSwap is a really mature protocol. We've worked on it a while, and the Go implementation is pretty efficient, and it does a whole lot. There are some challenges, though. BitSwap, because you only ask for one block at a time, there's certain types of nested traversals, like fetching a subdirectory deep in a graph in a nested directory, where they produce lots of round trips to get the data, because you don't know what the CIDs farther into the graph are. You have to ask for the first, and then the second, and then the third, and then the fourth, all the way to get to your end. And that's pretty inefficient. Also, BitSwap, for people sending data, since you're only getting very small requests, it's pretty hard to optimize your disk I/O and your network I/O, so you can send lots of data at once. Finally, the block level nature of BitSwap does tend to produce a lot of network traffic, similar to the traffic congestion problems that you see in BitTorrent. And this has resulted in, and the other part is not a problem with BitSwap itself, but the implementation of BitSwap that we've written for IPFS, the Go version, has kept growing and growing and growing. So it's way more than a protocol implementation. It's almost an entire data transfer stack. And it's so tightly integrated with Go IPFS that it's almost impossible to pull them apart. So it's not surprising we ended up writing a second transport in the context of building an entirely new technology with Filecoin. So the new transport is called GraphSync. It's kind of our new hotness, and it powers all of the data transfer in Filecoin. And GraphSync is a protocol for replicating entire IPLD graphs across peers. Rather than request a single block, in GraphSync, we request a SID and a SID selector. And that allows the peer to stream us all the blocks that match that query. In essence, we're performing an entire query against a remote IPLD data set. And we can ask for and receive much more data at once. We developed GraphSync because we knew that for storage and retrieval deals, we would require fast point-to-point transfers between clients and miners, similar to HTTP. And GraphSync, because the person sending data processes much higher level requests, they can read and marshal their data ahead of time and send it over the wire. So there's no extra round trips, and we should be able to max out to the speed of the network pipe. And since we started from scratch, GraphSync is a lot more configurable than BitSwap. We support custom authentication, sending side channel information like payments, and distributing individual requests to different data stores. On the receiving side, a lot of these things are easier to deal with when you're dealing with higher level requests. And this configurability has enabled some of the really cool optimizations that we're starting to see in Filecoin that you may have heard about, like the DAG store. It's allowing us to do I/O at much faster speeds. And we're starting to support really large storage clients like Estuary that are sending out tons of data at once. And that kind of scalability is just really hard to do with BitSwap. But GraphSync has its own challenges. First, because you're dealing with large requests, it's harder to break them up. It's not always clear how to break up a selector among peers. And second, we want to maintain our guarantees around incremental verifiability, and that turns out to be fairly complicated. So our implementation is complicated. The other challenge with GraphSync is you need a greater shared understanding on both sides of the network transport. Because the responder is essentially doing an IPLD selector query, they have to be able to execute it locally to get all the data. And this gets complicated because IPLD is pretty extensible and supports a number of customizations. And finally, again, this isn't a problem of GraphSync, but Go BitSwap does so much, and it's so much more than a transport protocol. So when you start a new protocol, you don't have all that, and it's just missing. So we've got some challenges. And probably our most obvious challenge that you may have been apparent up till now is that we have two different stacks. We have a transport stack for IPFS and a transport stack for Filecoin. And it's not just BitSwap and GraphSync. It's all the services that we built on top of them. In BitSwap, we have BitSwap sessions, which is sort of an optimization protocol for doing higher level transfers. And then we have services like the block service and DAG service that are baked on top of BitSwap and hard-coded into that. In Filecoin, we have GraphSync, and then we built other components on top of it to support Filecoin's needs. We have a control protocol called the data transfer protocol. We have a Filecoin retrieval protocol and a storage protocol. And finally, we have this support for payment channels so that we do, in fact, support paid transfers in Filecoin. But the larger problem is that data retrieval is about so much more than transport protocols. To build interoperable solutions, we need to think holistically about what the data transfer process looks like, so you can download any content for any protocol from any peer. And so we've started to do that, and we've identified 3 high-level steps in the data retrieval process. The first step is content routing. This is essentially finding your content. In the regular web, you ask users to know website names, and then you use DNS to find those websites. In the distributed web, we just start with a content identifier that could be hosted anywhere. And we need to track down who has that content and how they're making it available. We've developed, again, different solutions here. With IPFS, we have the DHT, or distributed hash table, which enables us to find any content on IPFS, even though it's sometimes not as fast as we'd like it to be. We also have a BitSwap want protocol that enables like speeding things up among local peers, because you can ask them whether they have a block without them actually sending it to you. On the Filecoin side, it's really still early days. Will Scott gave a talk earlier today about the indexing solutions we're building to help people find content on Filecoin, but a lot of it is still in development. Once you've found content, it's actually not an immediate step to making a transfer. We need to plan the best way to get it from potentially multiple sources. And there are a lot of factors we need to think about. We want to get it fast, and we know we probably want to get it free or low cost. But that might mean we're distributing the request over many peers, or switching between protocols, or making trade-offs to maybe pay to get things faster. Plus, we have to recover from failures if peers turn out to not have content. Concretely, almost none of this exists for Filecoin content today. It's largely manual. We do have a lot of planning in IPFS in BitSwap. That's what the BitSwap sessions largely do. It's really great. It just only works for BitSwap. Finally, we have what I've already been talking about, which is transport. How do you get things from one place to another? And here we have really great protocols, but there's one thing missing. And that's accessing all of the Web2 data. Right now, to use our protocols, you have to run an entire libp2p stack. What if we could bring some benefits like content and identifiers and incremental verifiability to data that's available only on the traditional web? So I want to talk to you briefly about how we're going to figure this out going forward. We know we want people to be able to download IPLD content from IPFS, Filecoin, and even maybe HTTP as fast as possible without having to think about where it's coming from or what protocols it's sent by. Wow, that's a tall order when you say it all together. Well, the good news is we've begun work on a prototype client that can retrieve data from IPFS and Filecoin, automatically choosing the best way to get it. So that's really good news. So how are we going to do this? The first thing we're going to do is we're really going to cleanly separate these stages of data retrieval I've been talking about. While all of these steps are asynchronous, they are distinct. We want to separate finding content, planning requests, and executing transfers. Now, it's not entirely that simple because feedback goes both ways in a large transfer request. We still want to be able to swap, but we still want to be able to swap different solutions at each step. What we're thinking about content routing now? It's a problem of finding content from multiple sources. Some of them are fast, but have very little content, like a local data store or local peers. And some of them are very slow, like the IPFS DHT, but have tons of content. We already actually do this without thinking about this in our IPFS stack, but we know there's going to be more sources over time. So we need to build a framework for fetching from multiple sources. And honestly, we know other people might build better solutions for finding content. So soon you're going to see delegated content routing coming to IPFS. And in our new retrieval stack, we want to allow people to plug in their own solutions at each level. The fastest way to get to an awesome retrieval client that downloads fast from anywhere is to provide a framework in which people can discover and implement the best-in-class solutions for individual parts of the problem. Solving planning is not obvious. The planning stage is going to be a complicated one. It's not easy to mix protocols and peers and payments and always deliver the optimized solution. We have some thoughts, but they're just preliminary. For BitSwap and GraphSync, we think we can mix them and get the best of both worlds. GraphSync helps us understand whole graphs and get them in a single round trip, but BitSwap is good at splitting requests. So what if we use GraphSync to get a description of the graph in terms of SIDs and BitSwap to actually fetch it? This is just one of the proposals for how we could get the best strengths for each protocol. And we're just going to have to evolve solutions over time. One other thing we are definitely considering is HTTP, and we've developed a proposal for incrementally verifiable transport over just HTTP 1.1. So when is all this coming? I don't know, 2022. This is not a product announcement. This is not your FVM keynote. So we'll hope it's going to be very soon, but it'll be even faster if you help out. So thank you very much, and beware of the spiders from Mars. Thanks.
Oh my gosh, Hannah, that was the best presentation. Again, not to pick favorites, sorry. Andrew and Charles, they were in the running, but they have now lost out because you put so much David Bowie into your presentation. So thank you so much again. That was also super interesting about the CIDs. That to me is the big unlock from Filecoin and IPFS. So, all right, we are now at our last session on the exit velocity track. We've got a talk on consensus scaling and sharding for Filecoin. We've got Marco, a consensus lab lead at Protocol Labs, coming up to the virtual stage to cover the challenges to blockchain scaling, and also how Protocol Labs is tackling those challenges to make sure Filecoin scales. I also hear that Marco is coming from a hotel party in East Africa, and so he will not be on video, but he has a presentation for all of us, and I have started drinking wine. So cheers, Marco, to you being at the party. Take it away.
Thank you. Hello, everyone, and thanks for the introduction. I hope you hear me well because I'm really joining from East Africa. It's past midnight here, and I found a really nice location here by the pool where you hopefully cannot hear the party. So yeah, with that, let's start with discussing how do we scale Filecoin. So this is the work that we're doing inside the Consensus Lab, which didn't exist basically when Filecoin was launched last year, and Filecoin Orbit is celebrating 1 year of Filecoin launch. So let me introduce just briefly what Consensus Lab is about. So this is the basically the new established lab in the Protocol Labs research and development, and we are working together with a network of academic and collaborators from other Web3 projects on basically bringing the state of the art in consensus and scalability research to Filecoin and IPFS, but not only Filecoin and IPFS, but the goal is to impact the entire Web3 ecosystem. So essentially, consensus is the bottleneck, if you want, of all decentralized systems. So we know from Bitcoin and Ethereum, Bitcoin is limited to 7 transactions per second and Ethereum to 15 transactions per second. And the point here is not, depends on your goals, right? So choosing the right consensus protocol is important depending on your use case, but any consensus protocol that you choose. So, you know, even if you come with a less secure protocol than proof of work, but which scales better, it's going to still be limited with a single machine, single validator specification. Because if you're running a consensus protocol, this means that you're ordering transactions, and then you're doing with transactions on each and every machine. You're doing something like the same thing on each and every machine. So whatever is your consensus protocol, depending on what is your use case, you're like regardless of that, you're going to be limited by the performance of a single machine. And then as we're moving towards decentralized internet from pure let's say simple transaction processing that Bitcoin has, right? So Ethereum has smart contracts, and we in Filecoin, we store large amounts of data, and the goal here is really to come up with decentralized internet use cases. So we need to basically support execution of arbitrary programs over the blockchain. So in that case, even if you use consensus protocol to order transactions, what you're doing later with them is really important. So currently, smart contracts supporting blockchains, they execute sequentially all transactions after ordering, and that's going to be another bottleneck in your system, right? So if you're not able to essentially remove the scalability bottleneck in the execution, you're going to face problems regardless of your consensus protocol. So what are essentially the scalability goals for Filecoin? So when I joined the Protocol Labs, and when I was thinking, like before I essentially established Consensus Lab, I was thinking, okay, let's take the best consensus protocol there is, let's put it in Filecoin, problem solved. But then Juan basically came with this really nice requirements, which is let's get all the entire Web2 workloads to Web3. And this is basically the setting in which we are working. So this is our running use case, which is extremely ambitious, but it also tells you something, like it drives design of consensus scaling in certain directions. So I won't read out all the requirements that you see on this slide, but basically you shouldn't sacrifice, like the latency in certain use cases should be very, very small, which is completely opposite from what you want in throughput, which should scale to, the billions or trillions transactions per second, but you should get as much security as you can. So for example, as we see today with Bitcoin proof of work, the fact that it uses more power than, Poland, which just means that Poland, if it engages all the power available to them, it's not able to attack Bitcoin. So we should be leveraging this security, right? So we should, I'm really not against Bitcoin spending a lot of energy, but we shouldn't be spending yet more energy, compared to Bitcoin, but we should kind of understand how to use such a secure network to secure Filecoin. As you will see, because scalability involves trade-offs when it comes to security and decentralization, this is one of the design approaches that we are taking here. So for example, leveraging security of other networks, notably Bitcoin. So how do we get to these bringing Web2 workloads to Web3? So one thing is that what I just mentioned. So you're not going to be able to run, basically because of a single machine scalability limits, you're not going to be running a single blockchain that basically runs the same code on all machines. So that's not going to fly. So what we are imagining is a hierarchical consensus approach, where you see here in green, basically the green line here you could think of it as the current Filecoin main chain. And we can maybe down the road change the consensus protocol Dale to scale even better. But even if we keep current Filecoin expected consensus, how we are going to actually do the scalability is by sharding, but not in a classical way, but by establishing hierarchies of consensus protocols. So essentially, when we spawn here in this picture blue and later yellow shards, they are going to leverage the security of basically their parent shards. And you see the checkpointing here shard, which is an external one, and I will talk a bit more about this. Here we plan to use the blockchain, basically the consensus protocols with even more security, such as Bitcoin's proof of work, to essentially increase the security of the Filecoin network. Of course, when you move from a single shard to multi-shard space, you have the main challenge is, of course, the security of individual shards, but also what do you do with cross-shard transaction semantics. So this is one of the things we're looking at. And consensus, basically the second pillar of the problems that we're looking at in Consensus Lab is, what do you do now within a specific shard? So that depends. Basically, in a shard, you will have a different number of nodes, depending on whether this is a Filecoin main chain, which currently has like 3.5. Last time I checked Filefox, I saw 3.5 thousand miners, and this will increase over the time. But you can imagine that in the child shards, we will have less and less nodes. And this will allow us to actually put very efficient protocols in these child shards. And finally, this is extending basically what Raul was talking today on Filecoin VM, but basically it also relates to what I said 2 slides ago. If you have this scalable sharding solution, and if you have really, really efficient consensus protocols inside the shard, it still doesn't mean much if you're going to be bottlenecked by sequential execution. So what we're looking at the Consensus Lab is essentially we are interfacing with Filecoin VM team, where they're of course bringing the Filecoin VM and supporting Wasm and EVM on top of Wasm and whatever Raul was talking about today to basically parallelize this computation. So this is one of the tasks that we're looking into in Consensus Lab. So I would say if FVM team is looking into to a certain extent in this third pillar, we are also collaborating with them on that. And our focus is basically on these 2 pillars, consensus hierarchies and consensus proper. So this is the focus of this newly formed team. But how do we do that? I mean, many teams are looking into this. And of course, it's easy to say, yeah, of course, we are going to scale and shard Filecoin, but how do you do that? I mean, as we know, the key problem when you do scaling and sharding is that you start losing security and decentralization. So this is the thing, right? So it's by now we have since Bitcoin like 12 years of research, and we still, like, if we have a consensus protocol such as proof of stake, yes, it has better performance than proof of work, but you're sacrificing a lot of security properties, right? So one of the challenges, and I will illustrate this on a very simple variant of proof of stake, but it also applies to proof of space-based protocols such as Filecoin expected consensus, is this notion of like there are a bunch of attacks, but I will try to explain quickly the long-range family of attacks. And basically, if you imagine that in this picture now, in the configuration, in the initial configuration, you see the arrows 1 and 2 in which client talks to consensus configuration, which consists of validators A, B, C, and D, and then they transfer some stakes. So, for example, B and C, they transfer their stake to E and F. This is arrow 3, and the arrow 4. A and D transfer their stake to G and H, right? And now you see that this completely changes the configuration of proof of stake system, or just any Byzantine fault tolerance system. I have here in the picture BFT system, which stands for Byzantine fault tolerance, which is actually you can see it as a variant of proof of stake. If the client knows only the initial configuration, when going to the picture down, when it starts to basically talk to the blockchain configuration consisting of A, B, C, and D, it might not know about E, F, G, H at all. Basically, it can be forked because these A, B, C, and D have no stake in the system anymore. So basically, if they keep cryptographic keys that they use to construct the blocks before, and basically in any rational model, they will be able to do that, they can fork the client. So this doesn't, I mean, this is something that this is a very, very basic attack on proof of stake, which doesn't appear in proof of work, because in proof of work, you can show basically the longest chain to the client, and client will immediately switch there. But here, there is no way, essentially, that the current configuration, EGFH, can convince the client that they're the right, essentially, configuration as compared to A, B, C, and D. And this is the problem that proof of stake alone cannot solve, right? So what we are doing, and it applies also in to proof of space, right? And it could apply in theory to current Filecoin. What we are doing there is basically what I was intuiting so far. So to prevent this kind of long-range attack and to essentially have more security in the Filecoin, in the main chain of the Filecoin network, we are working on anchoring and checkpointing membership and essentially the state of the Filecoin network into the Bitcoin network. So originally, this work was supposed to do this on Ethereum, but since Ethereum is changing to proof of stake, you cannot do this, right? So you actually need to, because of security provided by proof of work, you need to rely on a protocol that is not subject itself to this attack, which makes us go to Bitcoin. And there is an interesting upgrade that you might be aware of, which comes in November on Bitcoin, which is called Taproot, which allows basically single signature transaction, which are coming from a large population of nodes. So basically supporting Schnorr multisigs in Bitcoin, which we are leveraging here. And then we are essentially just putting a checkpoint, which is our CID, if you want, inside the Bitcoin transaction. And then we are putting, of course, the CID with actual state to the Filecoin network to resolve it, right? That's basically checkpoint in our, so reusing other consensus protocols to actually give more security to Filecoin. But then, of course, we need to shard, right? So coming to the picture that I showed previously, all these child shards are essentially going to provide like less security than the main chain, but higher performance. And they're essentially, you can think of them as a variant of limited liability companies. So think of them as limited liability chains in which essentially security for a child shard is firewalled in some sense. So if there is a security violation of the child shard, it's restricted to that shard. So it doesn't affect the main chain at all. So once we start rolling this out, you know, if you are like, okay, what are these guys doing? I mean, I don't want to, you know, endanger my stake, which are carried from the Filecoin network. This works. I mean, you're safe, but you don't need to worry about that. Only if you're explicitly, essentially, have an account on a child shard, you will be affected. And then you can profit from better performance or whatever we are going to put out there. Depending on how much time I have, let me just quickly check. Yeah, I probably don't have too much time to go into details, but in this slide, we are talking about essentially details, how we checkpoint into Bitcoin. I think I mentioned the main principle already. So we are putting the content ID hash, which captures the entire state of the Filecoin network inside the op return opcode of a Bitcoin transaction. And the address from which funds move on Bitcoin are essentially controlled by the old configuration of power table, storage power table of the old configuration, and we are moving to the address which is controlled by the new configuration, depending on miners joining the network and so on. So this is the main principle. Of course, it will take me a lot more time to explain the functioning here. And for sharding, I will just say one slide. So what we are working on Yudico codebase. So this is soon to be public, and Yudico is a Lotus client fork, which differs from Lotus just in a sense that it has modularized consensus. So instead of just expected consensus, which is kind of entangled with the other parts of Lotus code, we now have this modularized, and currently it is going to support different consensus protocols. Currently it supports like simple consensus protocols such as proof of work and delegated consensus. Delegated consensus is where you just give to one validator the ability to mine blocks. So this is not a real fault-tolerant consensus protocol, but it serves us to essentially start playing and start prototyping on the Yudico network. Of course, proof of work won't be there. It's just a placeholder for more efficient protocols that we are going to do in this consensus proper pillar that I mentioned. So to do this, we are adding another actor to essentially Yudico, Lotus/Yudico, and this is called the shard actor, which controls spawning of the shard, joining, leaving the shard, and so on. What is the plan for 2022? Just quickly, so we are currently at the sharding and checkpointing into Bitcoin POC stage. We expect first POC to be finalized by Q1 next year, and then we are going to also interface with Filecoin VM team. Currently, sharding is looking only into current Filecoin networks. It's not looking into Filecoin VM. But then once Filecoin VM is ready, as Raul was saying earlier today, then we are basically merging this work with Filecoin VM, and then we are continuing on supporting sharding still on POC level, basically in Q2 and after that. This is again not an announcement of a product feature, but we are aiming to have by the end of 2022 progressive rollout of certain features and certain functionalities that I just described into Filecoin. As for consensus proper, we are going to put very, very efficient scalable consensus protocol into child shards. This should be also targeting like first rollout should be still in 2022. And yeah, I think you should have listened to Raul's talk on Filecoin VM, which is related to this, right? Just to wrap up, Consensus Lab was just established in Q3, so basically 3 months ago I joined, and I'm very happy how fast we grow. So we have an amazing team, which currently has Sarah as a research scientist, Alfonso as a research engineer, George as our TPM, and we have 2 external advisors just to try to grow faster. We are relying here on external advisors who are helping us a lot with the parallel and scalable execution and hierarchical consensus. And we have another research scientist who is going to be responsible for consensus proper, joining us in early, basically Q1. If you have, if you're listening to this, you're yourself interested in this, or you know people who might be interested, we are hiring, and please contact us. I think you know how. We are also not working alone in the Consensus Lab, right? So one of our goals is to really leverage the entire research ecosystem around the top researchers in consensus and sharding on all the topics I mentioned. And to this end, we had a 2-day conference just 2 weeks ago, where basically some of the participants who are recognized professors in the field says, okay, this is one of the easily best conferences, research conferences in post-COVID times, or who is who in our field. I just had 2 quotes here from renowned researchers, where we actually are trying to, get this larger research community interested in the problems that we are looking at, and hence have the leverage, right, to give them also incentives to look at that. And I think this is also a large set of interesting problems, and basically for them to help us make Web3 scale, if you want. This is just an illustration, hopefully to impress you, like where these, what are the institutions from which consensus-based contributors came from. And these are all the institutions that we are looking to collaborate in one way or another in the future. Thank you so much.
All right. Thank you so much, Marco. That is a very quiet party that you were at. Must be some sort of silent disco. But thanks again for that presentation. We have the keynote coming up next, but we're going to take a short break before then, but stick with us. We'll be right back.
Community members from across the world came together to celebrate the one-year anniversary of Filecoin mainnet launch.
of the Filecoin Orbit Summit, which has been happening over the past 2 days. Next up, we have Devin Finzer. He is the CEO and co-founder of OpenSea. And if you're not familiar with OpenSea, you have surely just woken up from a coma, because OpenSea is the biggest secondary marketplace for NFTs. You know, those unique and many times artsy at this point crypto tokens that people will not stop talking about. So OpenSea has seen such impressive growth in this last year, which that would be good enough for a keynote as is, but also the marketplace has integrated with Filecoin in an effort to make NFTs and the new digital art world that's springing out of that technology permanent and persistent for the future of Web3. So it is my pleasure to introduce Devin Finzer of OpenSea to this virtual stage.
Hey everyone, my name is Devin. I am the CEO and one of the co-founders of OpenSea, and I am here to talk about future of NFTs and in particular OpenSea's Filecoin integration. Maybe slightly less of a technical talk than the other ones, but hopefully should be fun. So a little background on us, I'll go through these pretty quickly, but what is OpenSea? Well, we're a peer-to-peer non-custodial marketplace for NFTs. We also build a lot of tools that allow collectors, creators, and partners to get involved in a new economy around the internet. And we've been around since late 2017. So I think most of you are probably familiar with NFTs, but put simply, they're unique assets with digital certificates stored and managed on the blockchain. And OpenSea is currently the largest secondary marketplace for NFTs. We allow any NFT to be bought and sold through a set of smart contracts. Something that maybe people don't always recognize about us is that NFTs go far beyond just collectibles. They can be really all sorts of things. So on OpenSea, there are experiments in, there are of course a lot of art projects, there's a lot of collectible projects, but there are also projects around music and audio. There are also things like ENS names, which are more like domain names. There's photography. And then one of the areas that I'm really excited about is gaming. So virtual worlds and other games have NFT components to them and can be bought and sold on OpenSea. Trading card games, event tickets. There's really a very wide design space for NFTs, despite the recent growing popularity of more collectible focused NFTs. So here's an example. This is a project called Decentralized, which is a virtual world. And one of the really cool things about this virtual world is you can own clothing inside of the virtual world and customize your avatar. So much like you might buy a piece of clothing in Fortnite, you can buy something in this game. But the unique thing is that not only can this NFT live inside of the game itself, right, which is shown here, it can also be bought and sold on secondary marketplaces. And you can imagine even a world where another game developer comes along and decides to integrate this clothing into their game as well. So there's these really early experiments in the gaming space that at OpenSea we're really excited about them taking off. So this is just sort of a reminder of kind of what does it mean to be an NFT. Well, we've had fungible assets like cryptocurrencies. We have these sort of semi-fungible assets, which maybe are interchangeable within a class, but non-fungible tokens are these kind of unique, one-of-a-kind type things. And then, so now diving a little deeper into the meat of this talk, which is to talk about some of the underpinnings of non-fungible tokens. So as a review, there are sort of three token standards out there today. The first is ERC20, which many of you are already familiar with. And this is basically a mapping from address to integer, which denominates how much of this particular coin user or an address owns. There's ERC 721, which maps unique identifiers. So for example, CryptoKitty number 1 to their owner, right? So ERC 721 sort of says, this unique identifier is owned by this individual or this wallet. And then a new standard that has been sort of emerging and popularized over the last few years is ERC 1155. And the interesting thing about this standard is it almost combines ERC 721 and ERC 20 in a single smart contract. So it says there might be many different classes of things, and each of those classes are fungible within each other. So you could have a class of swords and a mapping of addresses to number of swords, and then a class of shields and a mapping there separately. And what's interesting about 1155 is it can actually, it is sort of a superset of the functionality of both ERC 20 and ERC 721. So looking deeper now to talk about sort of where Filecoin and IPFS come into play, it's important to understand the anatomy of one of these standards. So if we look at ERC 721, the really important methods to think about are owner of is one of them. And owner of basically tells you for a particular unique identifier, who is the owner of that particular NFT, right? So that's really one of those core methods that kind of encapsulates what NFTs or digital ownership is all about. It's really just being able to look up the owner. And then the second really important method is transfer from. So the ability to transfer that particular token ID from one address to another. And of course, this is only, this is permissioned by the owner of the token ID, right? So if you're not the owner, obviously you shouldn't be able to transfer it. And then there are other sort of bells and whistles here. For example, approving another address to transfer your tokens, which you're probably, those of you who are familiar with ERC 20 probably have seen that before. But really owner of and transfer from are kind of the key ingredients for a non-fungible token standard. Now, the question becomes, let's say that we have an NFT. How do we actually tell the world what that NFT looks like, right? So let's say we have, CryptoKitty number 12345. Well, how does the world know that, that's a blue CryptoKitty with, this description and these attributes and all of this sort of rich metadata associated with it? That is, it's not intuitive, right? From looking at the standard, you see all of these different methods, but where does it say what the token ID actually is, like what kind of NFT it is? And so that's where token metadata comes into play. So if you look at the ERC 721 standard, there's this method called token URI, which returns a URL or URI that tells the world where is the metadata associated with this NFT. So for example, this token URI might return an HTTP URL. And that HTTP URL, marketplaces such as OpenSea can go and grab the data from and sort of get a sense of what this thing is. So as an example, here's some metadata that if you grab, it's actually the metadata returned from that URL. You can see there's an image, a name, a description, and an external URL. And so these are how these, this is a little bit of a diagram on how all of this fits together. So you have the ERC 721 contract, which of course has owner of, which tells us who owns the NFT. And then you have the token URI, which returns a string and should take in a token ID here and returns a string. And then this URI returns the metadata. And you can see this is an image, a screenshot of how this item would look on OpenSea. You can see the name is here, the description is right here, and then there's all of these different traits and properties. And on OpenSea, we actually go and kind of grab all of that metadata, cache it in our own servers so that it can be easily served to the user without us having to go directly to the blockchain and directly to the source of truth. And the other interesting thing about this is, now that there's a standard for metadata, these items can live in multiple different applications. So this this is a different like looking creature, but you can imagine the same creature that shows up on OpenSea can then be, brought inside of a virtual world like this one, which is called crypto voxels. And this open metadata standard really allows any application to go and build an experience around the NFT. In this, we also, one note is that OpenSea provides a convenient API that sort of deals with some of the challenges around massaging the metadata, merging the on-chain and off-chain data. But the point is that anyone can go and build an application that uses this NFT because it's sort of standardized to some extent. So that, I believe this is just the same slide, but so the challenge, of course, is that we, if we look at, for example, some of these URLs here, right, you can see that the image and the URL itself is just some server, right? So in this case, it's storage on Google APIs, it's hosted on Google, the image. That's not great, right? Because we really want this metadata to stick around and to be permanent, right? So that's where IPFS and Filecoin really come into play, is sort of where do we host this metadata for NFTs. Of course, we could store it on chain, but storing entire images and lots of text on chain tends to be pretty expensive. So that's where OpenSea kind of, started to work more closely with IPFS and Filecoin. And we really wanted to create an experience for people creating NFTs that would allow them to have permanent storage of their metadata. But we did have some design requirements on our side. So on our side, we really wanted a flow that was easy to use and wouldn't be extremely high costs for every single user, right? So we didn't want people to have to pay tons of money or even really have to submit a transaction in order to mint a new NFT. But we also wanted power users to be able to create these decentralized, unstoppable NFTs that do have fully decentralized metadata. So what we came up with for our end product was allowing people to mint NFTs for free. So I'm not going to talk about it in this talk, but we have a system whereby users can mint NFTs, what we call lazy minting. So without having to submit an on-chain transaction. And we default to metadata that's stored on our own servers. But then we also allow users to freeze their metadata by uploading to IPFS and setting their token URI by submitting an on-chain transaction. And in terms of how we implemented this solution, we used the NFT storage service, which was sort of a convenient wrapper around some of the lower level IPFS and Filecoin APIs. We did this asynchronously on our backend, so we would have a queuing system that went and uploaded the metadata, and our front end would kind of pull for monitoring the status there. And then we also, at OpenSea, we do everything through GraphQL. So we had this sort of like wrapper API that made a lot of this stuff more convenient for the front end. So yeah, now I'll go into a quick demo of how this looks on our website. So it's screen. So for those of you who aren't familiar, OpenSea has a testnets environment. So it's called testnets.opensea.io. And what's interesting about this testnets environment is it's sort of a version of OpenSea, but everything lives on the Rinkeby blockchain, which is, I'm sure many of you are familiar with it, but it's sort of a version of Ethereum, a testnet version of Ethereum. So this is like, you can kind of think of it as a whole different OpenSea experience on the testnets blockchains. So this is our creator tool. So I'll go here from Insight. So you click create, and this allows users to create brand new NFTs in sort of a self-serve way without having to go and deploy their own smart contracts and develop it themselves. So if we go here and upload a new image. We'll say IPFS test NFT, and we can include lots of rich metadata about this thing. So we'll make it a link to a website, and we'll give it a description. We added it to a particular collection. And another thing that's kind of cool about our collection or our item creators, you can give it properties. So personality, you can give it numeric traits. So this is just kind of me demoing stuff. You can also do other things, but we'll skip those. And what's cool now is, so we're all ready to create. We click create. And because I've already signed with my Ethereum wallet, you see that I didn't actually have to submit any transactions to do this, because I'd already authenticated with my Ethereum wallet. And now the NFT is sort of lazily created. So it hasn't actually been minted on chain, but when we first sell it, it will become minted. And what's nice about this, again, from a design perspective, or sort of from a user experience perspective, is we can onboard users a lot more easily without having to have them pay tons of money in gas, right? Because at the end of the day, OpenSea is really a product that attempts to sort of make this technology more accessible to the mainstream. And so we really wanted to make it as easy as possible to create your first NFT. Now, but we go here into details and we see that we have the contract address, the token ID, but the metadata is editable, right? So because the metadata has been put on OpenSea servers, it means that we can go and edit it, right? And what we want to do is we want to actually create an NFT that's completely decentralized and is not editable by users. And so we go back here and we go to freeze metadata. And this will use NFT storage, IPFS, to sort of permanently, it'll do two things. So we can click freeze here. So first it's going to upload the metadata to IPFS. So that's what's happening right now, which takes a little while. And then the user will submit a transaction, which I can do right now, to do set URI on the item, which basically sets the IPFS URI for this particular token ID and permanently saves the metadata. So I'll click confirm here, and then we'll just wait for the transaction to process. All right, so the transaction is processed. We can go and look at it here. And then now when we go to this item, we can look at the details again. And instead of saying editable, you can see that the metadata is frozen. And if we click on this, we can actually see the IPFS URL for this particular metadata. So you can see, the image was actually uploaded to IPFS, right, under /image. And then the rest of this, the properties, the external URL name description are kind of what we see here. The other note here is that we actually will, one of the things that OpenSea does is we'll go and sort of monitor the different NFT contracts to tell users and inform them whether metadata is frozen or whether it's on-chain, or sorry, off-chain or on-chain, and to sort of educate users about, or especially power users, about whether these NFTs are truly decentralized or whether they're more centralized NFTs. Again, I actually don't think there's anything wrong with sort of NFTs that use centralized APIs. I think often that can be the right thing for like a game or something where where you don't necessarily need as much decentralization, but for art pieces, I think, it can often be important to collectors to be able to see that their metadata is not going to sort of be taken out from under them. So I think that's sort of the demo piece of it. Of course, we can go and sell this NFT and all that. So then back to the finishing up the presentation. In terms of future opportunities, I think this is sort of more broadly speaking, so where could NFTs go in the future? Well, I think there's actually a lot of room to improve on metadata standards and make them richer and more interoperable and just allow you to represent all sorts of things. You can imagine broadcasting that something is an event ticket or a game item or something like that. There's opportunities for on-chain composability. And then of course, there's like tons of opportunities to expand to new blockchains and also to layer 2 scaling solutions. And just the last thing is that OpenSea is actively hiring developers. So, we're always looking for folks to join the team, either on the sort of blockchain side or even just people who are excited about building consumer-facing applications on top of blockchains. So definitely reach out to me if you're interested in a position.
Awesome, cool. Thank you so much, Devin. That was actually really interesting to see that done in real time with the demo. So I just have a couple questions. How many creators are using the freeze metadata function and utilizing IPFS for their NFTs?
Oh man, if you had given me that question ahead of time.
Sorry, I didn't mean to put you on the spot, but is there even a range that you would know of?
Let me pull that up while you ask me other questions.
Okay, yeah, sure. Well, so I guess the other question I had was, as you've talked to creators who are using OpenSea, is there hurdles that they talk about in utilizing IPFS and Filecoin that maybe the Filecoin ecosystem should think about as they develop upgrades to make this easier for creators?
Yeah, well, I think, I can bring that to my team and see if they have any feedback. But I do think for the most part, the NFT storage API was really friendly to use. I think, I don't know what the state of NFT tutorials that sort of bundle together, issuing NFTs and having metadata. So the developer, we try to make our creator tools as easy as possible and kind of simple for users, but I think anything that helps a developer go from 0 to fully decentralized NFT with metadata would be valuable, right? So just a sort of higher level API for doing that, I think would be cool, but that might already exist. So.
Yeah, that's fair. And then in terms of, you had sort of talked about some NFTs probably don't need to be on IPFS. And so I guess if you can talk about those two differences that you're seeing in the NFT market, what is that narrative in terms of, these fine art NFTs, if you could call this this group of people fine art at this point. I think some of it's very fine, but so maybe the fine art needs to be on IPFS, but you were talking about the gaming. So just expand on that part a little bit.
Yeah, sure. And I have a few numbers in terms of kind of the number of people using this frozen metadata stuff. So it's been growing significantly. So it looks like in September, we had around 78,000 unique uploads of metadata. So that's not unified by user, but it's sort of number of times people have uploaded metadata, which is, maybe it's not a huge number, but I do think that this is a pretty hidden sort of power user feature. And the fact that it's been growing, I think in August, it looks like it was 25,000. So significantly up from that. I think I'm pretty excited about, that number of people using the feature. And again, it's, it's sort of a feature that is really just for people who are creating NFTs, not just people who are buying. But then, yeah, to answer your question, yeah, I think it's a good question of whether all the data needs to be decentralized. I guess maybe it's just sort of a practical consideration. Like if you're building a game where for example, a lot of games sort of generate their game items deterministically based on like the properties of the thing, right? It's hard to manage like uploading, to a decentralized file system for every single different game item. And then the other point there is just like, if the game goes away, then the game item's kind of not very useful anymore. So even if the metadata was like stored on a decentralized file system, well, you can't play the game anymore, right? So it's like there's already sort of a central point of failure. And so how much does it matter whether the metadata is centralized versus not? That's kind of my point.
I see. Yeah, that's a good point. I hadn't really thought of that. Although I guess there's this broader narrative that your skins or your characters in one game, if that game fails, maybe you'll be able to take it into a different game. And so if you really love that character, maybe that is worth it to have that, persistent over Web3.
Yeah, I think in the future, it's more of a practical consideration. Like in the future, when we have like unstoppable games that are like built on peer-to-peer systems and there's no more games like centralized game server. I don't know, I think that's much further down the road. But when you can create those sorts of things, I think having everything be decentralized is super important. But a lot of games are just like sort of this hybrid right now.
Yeah, that's fair. Okay, Devin, thank you so much for joining us at Filecoin Orbit. That was awesome. Like I said, I thoroughly enjoyed having that demo. I learned by experience, and so that was great. So thanks so much.
Thanks for having me.
Yeah, no problem. And now for our closing session, we are wrapping up day 2 of Filecoin Orbit. And this is it. We're bringing on Colin Everin of Protocol Labs. He's going to give us an overview of all the amazing things that happened on day 2 and tell you more about how to get involved in the Filecoin ecosystem if that is what you want to do. So Filecoin, I'm sorry, not Filecoin. Colin, please take it away.
Bailey, my friends call me Protocolin, but you can also call me Filecolin, so you're not far off in the introduction there. Hi, everyone. I'm super excited to talk about just a few highlights over the last week here. But before we do that, our production team has put together just a quick highlight reel of kind of the last couple of days here. So I'm going to throw it to them and introduce that video.
Community members from across the world came together to celebrate the 1-year anniversary of Filecoin mainnet launch.
I'm Nancy, one of the co-founders of IPLD News. I came from Shanghai, China.
Welcome to Filecoin Orbit community event for East and Southeast Europe.
If there's data everywhere in every major city, we can help funnel data to those storage providers. We have 17,000 deals on chain as of last week.
3,300 Filecoin storage providers have contributed nearly 12 exabytes of storage capacity.
To be able to store application data, to be able to store data sets.
There's a tremendous amount of innovation happening, right? Because this is a new infrastructure for financial services, for the internet.
So is the first year that the Internet Archive has started uploading parts of the web archive into Filecoin.
Coin is the file and the file is the coin. It's a transubstantiation racket, a crypto economic packet. It's a virtual state machine, replicated, proven to be obscene.
So from NFTs to Web3 dApps to large data, we're really turned Filecoin into being the place where your Web3 data is stored, persisted, and accessible.
Let me talk a little bit about this thing that is going to make all of this on-chain innovation possible. User programmability had always been part of the roadmap.
Huge kudos to the team who actually did this hyperdrive upgrade less than about 8 months into the network.
Everything that's going on is being persistently stored in a decentralized storage mechanism, like Filecoin. And this is what a hybrid smart contract is.
Over the last 4 days alone, we've had 35 events in 12 countries, 5 continents, and 20,000 or more attendees. And so to the organizations, the individuals that are investing in the Filecoin ecosystem, thank you. This is absolutely just the beginning. That is just incredible. Just an amazing kind of slice up over the last couple of days. I'm told all of the content over the last few days will actually be available sometime this weekend on YouTube. So in case you missed a session, I know there's so much incredible content. Please take a look. Watch out for those. We'll send in an email or a newsletter once it's up there, and everyone can enjoy this content once it's up there. So I was thinking about doing just a quick day 5 recap of some parts of the week and also what happened today. So I'll get right into it. It's obviously impossible to put everything that's happened into the last year in the Filecoin community on one slide, but this is my feeble attempt at doing some of the highlights on one slide in the interest of time. In 12 months, the Filecoin community has built one of the largest data storage networks on the planet, which is absolutely incredible. We're estimating it to be roughly the size of Google Cloud in 2018. They built the least expensive large-scale storage network in the world, less than 1% of the cost of centralized storage today. The community has built the fastest upgrade in the blockchain, more than 10xing the available chain bandwidth within 8 months of launch. The community has built an environment where builders can thrive. We have 10,000 developers thriving in hackathons, 250 applications live today, 500 new teams entering the ecosystem. We built the storage network of Web3. Over 7 million NFTs are stored on Filecoin, and we have integrations with about 75% of the largest smart contract blockchains in Web3. And we built over 25 categories of use cases on Filecoin, from NFTs to video to audio to the metaverse to all sorts of new use cases that we're seeing today. And when you think about the next year, I really believe the Filecoin community will catalyze huge innovations, many of which that were presented today. New use cases being enabled by the Filecoin virtual machine and EVM compatibility, scaling chain state and computation on the Filecoin network and improving the retrieval markets, the former of which can enable massive amounts of transactional throughput. Making Filecoin green and enabling Filecoin to be carbon neutral or ideally carbon negative. Catalyzing the next 1,000 startups in the ecosystem in the next 12 months. Dramatically scaling the valuable data stored on Filecoin. There are actually hundreds of petabytes of data waiting to be stored on Filecoin today, and so I'm so excited to kind of cross the border and store all of that and more. And finally, accelerating the transition from Web 2 to Web 3, enabling large Web 2 clients and applications to adopt Web 3 tech using IPFS and Filecoin. So that's a quick snapshot. When you think about Filecoin Orbit, the last 5 days have just been such a massive success and just an incredible pleasure to see so many different faces in the community present all the amazing work that they've done. Over the last 5 days, we've had 35 events in 12 countries, over 5 continents, and 23,000 attendees and counting. And I'm sure once we post the content online, that'll continue to increase in the hundreds of thousands. We've had community events throughout the week covering topics like developer tooling, protocol improvements, NFTs, green Filecoin, policy, decentralized finance and fintech, the metaverse, Web3 storage, enabling Web2 storage of data sets, the Filecoin retrieval market, and much, much more. And these have all been led with such incredibly passionate and organized community organizers from around the world. These are just a few of the names that have just put their hearts and souls in the last few weeks to make sure that these events have been a massive success. So my heart goes out. Thank you so much for organizing these incredible events. They've been super powerful for the community and have enabled a whole variety of opinions about the Filecoin ecosystem to emerge, which is super healthy. We have just a few pictures from the community events this week. We have some live events in Asia, Greening Filecoin, which is an amazing event a few days ago. We have live coding demonstrations. This has really helped augment technical areas. We had a workshop on building the Filecoin yield curve and decentralized finance on Filecoin, and another one in Europe. We've had a recruiting event, which was awesome. It was actually held in Gather, where folks could interact with each other. We had an amazing meetup in Lagos as well, and a few live events in Asia as well. And just yesterday, we had some amazing keynotes, including Brewster Kahle from the Internet Archive, Sergey from the Chainlink community. We had ZX talked about hyperdrive. Isaac talked about their Techstars accelerator, focusing on the Filecoin ecosystem. We had Stephen Lee talk about how much progress the Venus implementation has made. And when you go into today, I can't even put together all the amazing bits of information, but I'll start off with the introduction of the Filecoin virtual machine with Raul, which kicked off the day, which really unlocks a whole bunch of different use cases on the Filecoin ecosystem. So I'm super excited for that to come to fruition. Andrew Hill did an awesome presentation called Under the Bridge, which featured a whole bunch of the work that Textile is doing. Jonathan Doughton featured a bunch of amazing work that the Starling Lab has done over the last year, including the Shoah Foundation and the Stanford Engineering Department, putting so many valuable data sets on the Filecoin network. And Ricardo actually, on this bottom right corner, ran a meetup in Italy yesterday, which was absolutely incredible, celebrating the last year of Filecoin. To go on, Alan Ransel did a kind of a synopsis of the Filecoin Green Initiative. The Phil Swan team did a presentation of how some of their dev tools are enabling the metaverse. Angie Lau and the Forecast team ran a live meetup in Hong Kong last night. And so you'll see a few pictures on the right-hand side of the slide there. It was really well attended. And Porsu did an amazing presentation on metaproofs, which was a new primitive that's being implemented into Filecoin next year. Dietrich interviewed Ani from Brave on some of our browser strategy with IPFS and Filecoin. We had, I believe, I'm going to mispronounce this, but I'll give it a shot. Chuklamika, who did a meetup in Lagos yesterday, which was absolutely incredible. Kuba presented on Snap Deals, which is a lightweight way of doing committed capacity sector upgrades. And we had David from Lit Protocol and Renil from Audius come join a panel on music, media, and culture, which really featured a lot of the creatives building on Filecoin. And then finally, we had a number of startups just coming into fruition here that presented their progress really in the last month. So all these startups actually had demo day just a month ago, and they had so much incredible progress to share in the last month that we had a lot to learn from them today. We had Mona present, Convo Spaces, WeatherXM, and CID Gravity, all of which had amazing updates to share since their demo day a few days ago. Now, if you can believe it, day 5 is not the last day of Filecoin Orbit. We have some incredible events tomorrow and on Monday. So I'll preview these right here. Tomorrow, we're doing a Web3 Metaverse Traverse on Filecoin Orbit. This will be an online event. On Saturday, we're also doing a Filecoin Orbit event in Warri, Nigeria. This is led by Charles, which is a super engaged community member in Africa. We have day 3 of Orbit Lagos, which is incredible. And then on October 25th, this is actually during the Wangsheng Blockchain Week, Bytebase is doing an Orbit meetup in the context of that broader conference, which is incredible. So please check out orbit.filecoin.io for details. The fun is not over. Please join some of these events. They're going to be incredible. Great. So I figured I'd just close things with some parting advice. I want to reiterate a few things Juan said in the opener today and add one more of my own. First, to the entire community, make sure you're thinking long-term. We are really building some of the building blocks of Web3 infrastructure, and the decisions that we make today will be embedded into the code for decades to come. Think of some of the early decisions made into the HTTP protocol that really are living with the consequences of some of those decisions, even many, many years later today. And so when you're developing a startup on top of the Filecoin ecosystem, when you're making contributions to the protocol themselves, please force yourself to zoom out 50 years from now and how some of the decisions we make today will impact things in the future. It's also just a great time to get involved because this tidal wave will only get bigger over time. 2, be resilient. For those who've been in the blockchain ecosystem for a while, we know there are ups and downs. We know there are tough challenges that we all need to overcome. So please break through those barriers. Be resilient in kind of our mission to create a better storage layer for the internet. And when obstacles come your way, please push through those obstacles in advance of our larger mission. And finally, be ambassadors. We have thousands, if not tens of thousands of folks joining our community every month. And some of them are ready to build their first startup on Filecoin or IPFS. Some of them just want to follow along and be engaged community members. The quality of our community and how we invite and embrace those new community members into our ecosystem, that's going to dictate the culture of what the Filecoin community is for years to come. We're super mission oriented, we're focused on the long term, we're resilient, and those are the principles that I'd love to showcase to new folks coming into our ecosystem. So that's all for today. I really appreciate everyone being engaged and active in discussions all throughout the day, through the tech talks, through the ecosystem presentations, through some of the builders showcasing what they've built on top of Filecoin over the last year. Thank you so much for being with us, and we'll sign off for today. Take care.